jazz club. Really flying the music. Okay. And it's so packed in here. The band sounds great. Double penny with some tracks. How are you? Oh yeah.
the great Lester Young.
jazz club. Really flying the music. Okay. And it's so packed in here. The band sounds great.
Lester Young.
Hey everyone, and welcome back to the second day at GitHub University. My name is Juan Pablo Flores, and I'm a program manager here at the GitHub Education team. We had a series of great talks yesterday with Cassidy William telling us about how to learn through teaching your community, Emoju with an incredible presentation on how to build your own talents, and Swift talking about internships and the amazing work that Major League Hacking is doing with the fellowship program. And finally, John on using GitHub to distribute classroom assignments at scale. There were so many fantastic moments from yesterday. What was your favorite? Let us know in chat. You can throw an emoji or just let us know which was one of the takeaways that you had for the calls or the talks that we have with some of the folks yesterday. I can tell you I was pretty inspired with Cassidy Williams' comments about how she grew as a professional developer by learning while teaching and the importance of saying you don't know when, well, you don't know about something. Oh, and also we had an amazing keynote from Nat yesterday. Has anyone tried dark mode yet? Let us know in chat how was your experience, and you can also let us know, or I can tell you that I was using dark mode yesterday while I was submitting my PR on Twilio Quest, and my eyes were so happy that we finally have this feature native on GitHub. Today we have a new host joining us. So I have the pleasure of welcoming someone really cool to the stream. Josh is a community manager for Asia Pacific region at Major League Hacking and also a GitHub campus expert, our program for students building technical communities on campuses around the world. Welcome, Josh. How you doing?
Thanks for the wonderful introduction, Juanpa. I'm so excited to be here today. GitHub education has been a great part of my student experience, and I cannot actually wait to share with you for the next 2 days the whole lot of different experiences I had and the different updates we have over that as well. As Juanpa mentioned, I'm the hackathon community manager for the Asia Pacific and the EU region at Major League Hacking. So it's my job to help organizers start their first steps towards making a successful hackathon. From being a hacker to an organizer to being a great part of this whole community that we have in MLH, it's been a journey. I've also been a campus expert, and this where we I've learned every different skill I need to know to become a community manager in the first place.
Yeah, I mean, being a community manager at Major League Hacking is a big responsibility, but also is one of the most rewarding jobs you can have. Not only you're helping other organizers and your friends to make amazing advancements, but also being able to connect with folks that are doing amazing work with their communities is by far one of the most rewarding things that you can work on in this industry. And we know the work that goes into organizing hackathons. So, Josh, I know you were part of GitHub Univers a few years ago as well. Can you tell me a little bit more about what was your experience like?
That's a great thing down the memory lane, I would say. It was really exciting to be in San Francisco for the first thing, getting to know all the different GitHub campus experts that were there, visiting the GitHub office, met so many amazing folks at Univers. And actually, the main part, swags. Everything on that universe is actually over in the shelf as well. So, so it was not just that. We had only 20 experienced campus experts over there at the event, and I can't believe this year we are going to celebrate with a lot more of you. This track what we have at GitHub specifically for the students this year, everything you need to know perfectly packaged in a single place. It's like sugar on top, perfect.
Can you believe that we went from such a small group of students to getting to share this experience with the entire student community? And not only share that with all of you, but also to have our own track at the event and get to talk today about all the work that the students are doing and the programs that the GitHub Education team runs. Today, we moved the event to the university lab. So grab your lab coats and get ready to get hands-on experience with the latest and greatest tools and technologies available for you without having to pay a thing, thanks to the GitHub Student Developer Pack.
Right. And the GitHub Student Developer Pack has grown tremendously when I first joined. It was about 25 partners at that point of time, 3 years ago, and we have grown it to more than 200, I guess. It is incredible. Like, we really have the things you need to get started, from hosting to get a free domain name, to designing games in Unity, to even discounts on microcontrollers, hardwares to help you get started. And not just that, the best part, you get GitHub Pro for free. And that is one of the things I use still, and I just love it.
It really has been mesmerizing to see how the pack has grown in the last years. If you're not part of the pack yet, we have the link for you down below. There's also the teacher toolbox with so many benefits for teachers as well. You just need to verify your academic status to get access to all of these benefits. So let's talk about some housekeeping for the day. If you weren't with us yesterday, we're asking for your help on one incredibly important mission, Operation University. That's right. We've heard that the flame of open source is under attack, and we must defeat legacy code systems trying to extinguish the open source development. This is your chance to win swag and compete to join the leaderboard by playing Twilio Quest. We have a link down below as well to join the mission, and we will be drawing the winners tomorrow at the end of the event. We heard there were some confusions about the links yesterday, so if you want to scroll down on the education.github.com/university website, where we have embedded all the Twitch chat already, we have all the links available for all of you. And some of you might be watching these directly on Twitch, which is totally cool, but head over to the website if you would like to see all the information about all the programs that we're running. Also, I wanted to cover a little bit more about code spaces. I don't know about you, Josh, but I've been so excited about code spaces and getting to know more about how we can code in a browser. I use it, as I mentioned at the beginning, in last night on dark mode. It looks amazing, and it really helped me out to get really fast into just coding that pixel and getting my contribution on that pull request working. Have you been able to use code spaces already?
Right. I used CoSpaces like last year when it was actually introduced, and I had actually a new laptop where I need to configure things. But I was like, wanted to try out a new project, like one of my old projects. I just wanted to run over that, and at that point of time, JavaScript was supported, and I was like trying it out inside the environment. Everything got compiled, everything got exactly in the right place, in the perfect package over there. I did not need to install any single dependency. It was all very well configured, and it was such a great experience, I should say.
Yeah, and I think one of the biggest benefits is if you are a student and probably you don't have the best laptop or a gaming PC in your home, you can use code spaces to code really big projects and don't need to have strong hardware on your home. You can do everything on the cloud. So you would only need to have an internet connection to be able to be part of code spaces. And I'm really looking forward to see what you're all going to be doing next with code spaces. Now, if you want to share some of the greatest moments about the event or share clips, let us know on social by adding the hashtag GitHub Univers tag on it. We'll be sharing some of your posts with our accounts throughout the day. If you'd like to chat in Twitch, you may have seen we have a code of conduct. Please take a look through it and accept the code of conduct to join the conversation. Now, let's get started with the day. So, Josh, tell us more about what we will be hearing today.
All right. So, what's on the schedule today? So, we'll be starting out with Kevin Vinery from TwilioQuest. This is one of the great ones for anyone interested in game development. Ken will share how fantasy, action, economy, world, story all come together to form a DNA of a game. And he'll provide a framework for making decisions how a game might work. Kevin is the brains behind TwilioQuest, and if you haven't joined Operation University till now, please help us save the flame of open source. It's definitely one of the cool things you want to check out to win great swag. Next up is a very special guest, the former GitHub Campus Experts Program Manager, the one who managed both Juanpa and I when we were campus experts. Juanpa, would you like to tell us more about Lika?
Of course, we are so excited to have her back joining us for today. And not only as a former campus expert program manager, but now as a GitHub student developer pack partner. Lika is joining us from MongoDB to talk with Michael Lin about being a pack partner and how you can get started with MongoDB.
Right. I can really wait to hear from Lika and what she's up to in MongoDB as well. So after our talk from MongoDB, we'll take a short break where you can check out some innovative ways of having code in VR create music and play over that on the play track, or take a few minutes to finish a mission in Twilio. It's up to you. Then we'll be back with University Track again, joined by Amos Johnson and Dr. Chris Headley for their talk about how GitHub can be used in a multi-college collaborative research. And how we are ending the day, Juanpa.
Our last talk of the day is on getting started with security by GitHub's own security lab researcher, Kevin Backhouse. He'll be sharing some of his story and how you can get started finding your first vulnerability in code. Okay, so let's get started. Who's our first speaker, Dash?
So, as I said before, our first speaker is Kevin Winery, the creator and the current team lead of TwilioQuest. I hope by now you had a chance to check it out and play through a mission at least. So Kevin has been a long-time JavaScript developer like me and known for his wacky fun projects. TwilioQuest, like working as he mentioned, was one of the most fun he had on it. And be sure to check any of the questions you have, post it on the chat, and we'll be collecting them for the Q&A at the end. So now, let's have a warm welcome for Kevin Winery.
All right. Thank you very much, folks. Much appreciated for the opportunity to be here with you today. As I said, my name is Kevin Winery, and I have the privilege of working on something called TwilioQuest, which we'll talk a little bit about later. But number one, I just wanted to say the Univers programming lineup has been amazing so far. Cassidy gave us a great intro to some of what I think are the important bits of how to think about yourself as a teacher, even if you're not an expert. And Emoju's talk about how knowledge is acquired as a software engineer is some of the best advice that you can get early in your career. Certainly the mistake I made as being sort of a passive good student back in the day was to assume that all the information I would need to be successful would be like transmitted to me by teachers, and then I would turn around and solve like neatly structured problems. But that's really not how software engineering works, at least not, interesting software engineering. You typically start with a problem that's big and scary that you don't understand, and you need to acquire the knowledge that you need to be able to solve that problem. So Emoju's talk about how you acquire that knowledge was really great to hear yesterday. So in the spirit of Cassidy's talk about teaching something that you are just learning yourself, I'm here today to talk to you a little bit about game design and the game design stack, which is a very useful construct that I came across on my journey to developing a game. So yes, my name is Kevin. You can find me on social media here at Kevin Winery. I'm on GitHub at KWinery. Unlike some of the other presenters, I've been less stringent about making sure I have the same handle on all those social platforms, but I would love to hear from you on any of those channels. And where my journey and our journey starts today is way back at that sort of what I would argue is the pinnacle of video game design. In the 1990s, there was a space flight simulator called TIE Fighter, which would put you in the cockpit of a TIE Fighter, a starfighter in the Star Wars universe. You would fly around blasting X-Wings and Y-Wings. And to young Kevin back in those days, it was the greatest thing that ever existed. And in learning how to play TIE Fighter, I first had to learn how computers worked, because if I can get back on the back in my day horse, back in my day, computers didn't just run the games you wanted them to run. I had to figure out like how to upgrade the RAM in my computer. I had to figure out how to create a boot disk and like boot a program from DOS, and how to like execute commands in order to make this game actually appear on the screen. So not only was it one of my first like formative video game experiences, it was also one of the things that made me want to get into technology and sort of pushed me into that world and made me realize like what was possible. And even back in those days when I was playing TIE Fighter sort of passively, I thought, man, this is really what I want to do. I want to be a video game developer. That's how I'm going to spend my career. It's going to be great. But well-laid plans often don't work out. My backup plan was to be a NFL quarterback, which also didn't work out. So where I ended up was building websites, which was super fun, and even better, I got to start working with developer communities. I became a developer evangelist. I worked on documentation for developers, and with Twilio and other companies before. My job was to make developers successful. And one of the things that I tried to do in that vein was to make learning Twilio or the Twilio API a little bit more fun. So back in 2013, over a week of sort of fevered hacking on AngularJS 1.0, I created kind of a gamified tutorial for Twilio that I called Twilio Quest. And being the huge dork that I am, I thought like, oh, it would be fun if, as you're going through tutorials, you gained experience points and you got like items that you can equip on your avatar. And I thought it would be fun. But what I didn't understand at that time was that these progression mechanisms and these gameplay mechanisms were the carrot that a lot of folks needed to like keep making progress in a field of study, in a field that is generally defined by frustration. So making that experience fun and using gameplay ended up being a really important tool for educating folks and getting them to understand harder technical concepts. And when we saw that developers actually really enjoyed learning in this way, we said like, all right, we're going to push in our chips and we're going to really say like, all right, Twilio Quest, we are going to make into a game, not just sort of a fun tutorial system, but we are going to try to make a honest to gosh PC game that we hope will be intrinsically fun. That's going to actually teach these programming skills. And further, we don't necessarily want it to be focused on Twilio. We want to teach folks how to use the command line. We want to teach folks how to install Python on their computer, how to use command line tools like Git, and actually start to use their computer like a developer. And that's kind of where we've ended up with Twilio Quest, which I think some of you have had a chance to check out already. We're still very early in the journey with this software, but we feel pretty good about how far we've come in a relatively short amount of time, and we hope that you've had a good time playing it. But when we kind of decided to make this decision and make the jump and say like, all right, we are making a video game, there was a problem. And that problem was I had no idea how to actually make a video game. I'd had lots of practice with video games by playing them myself, but I didn't actually know what it took to design a video game. Like I didn't really even know how to think about it. So I started to kind of look around for frameworks and ideas about like how to organize your thoughts when you look at the process of building a video game. And one of the tools that I came across one year I actually got to go to the game developer conference back before the fall of human civilization when we could still do live events. I went to San Francisco and I went to a talk from a panel of great game developers. And this was one of the things that really stuck to me and helped me think about what Twilio Quest was really about. So for the prospective game designers among you, I thought I would share this conceptual framework for you to think about how a game works and also how to make decisions about where to invest your time. For most of us, we don't have unlimited time and resources, so we really need to focus on what's important. And the different elements of your game's design are all have the capacity to be really impactful and important. But really, you have to make some tough decisions about where to anchor your experience and where you're going to invest your time. So in the game design stack, I'm going to kind of talk about it from the bottom up, and hopefully it will become clear why as we go. But sort of the bedrock of a video game and kind of the thing which distinguishes it from other media is the concept of a fantasy. In a video game, you can put the player in the shoes of someone or something else. And that's, you can try to do that with prose in a book. You can try to do that with imagery in a film. But through a video game, like you have the superpower of being able to tap into human empathy and literally put somebody in someone else's shoes. Empathy is like the graphics API by which you will render your game into the hearts and imaginations of the folks who play it. So, thinking through what is the person or the thing that you want to transport your player into is a really useful place to start when you're thinking about what your game is about. And one good example of this is the recent Spider-Man game on PS4, is where I recently played it. And more than any game I played in a really long time, I was the entire time just like, yeah, I'm Spider-Man. I'm out here doing Spider-Man stuff. I'm flipping around buildings. My cell phone is blowing up. And it's my aunt or my boss who's telling me I'm late for work. And the ways in which they weaved all the elements of that game together to create the illusion that you were Spider-Man was really first rate. So that's an example of how you create a fantasy and create that empathy within a game world. After that, you start to construct the action. And the action of a game is just the stuff that you do. What are the players actually going to accomplish while they were playing the game? And one example of a game that's sort of anchored in action is something like a sports game, like Madden, where there isn't a lot of story, there isn't a lot of narrative potentially around the gameplay. It's really about doing the thing. It's about making a pass. Or a first-person shooter or something is another game that's very rooted in action. And the economy is basically the set of rewards for the actions that you undertake within the game. So you successfully slay a dragon. What happens afterwards? What do you get? And what can you do kind of with the currency or the points or the other things that you earn while you're in the game. And there are some games that are actually just economy. So like something like a farm simulator, there is no real gameplay element other than managing the economy of your character and the other rewards that you're getting through the systems of the game. And these elements exist in some kind of game world. So the world is the story that you tell with the environment in which you place the player. And just by using space, you can convey a lot of information that you'd have to burn a lot of books or a lot of words in a book in order to convey the same sense of world that you can do in a video game. And I think a great recent example of this is like the Breath of the Wild. If you've played the most recent entry in the Legend of Zelda franchise, where the story of the game is actually not super interesting, right? Like the dialogue is pretty stilted. It's a pretty generic adventure story, but like where the game really comes to life is in how cohesive the world is. And that's where you start to like see the real story and the real, imagery of the game really pop out. You explore the ruins of a castle town that was decimated by walking robots. And you feel, at least for me, I felt in the pit of my stomach, the remorse of like this town that was so clearly like torn apart by this, by these terrible robots. And that is where it really exposes the texture of the world to you, is in the environments that you explore, the fact that you can go anywhere and do anything. So world ends up being a really powerful component of design in that sense. And then finally, we have the story. So this is the reason why things are happening in your game. And for some games, story is everything. It's the primary component. And for some, it's barely necessary. But every game has to have something of that nature. You are here for some kind of reason, and this is the thing that you are doing to accomplish that goal. And some of the games from Supergiant Games, Transistor is the screenshot that's up on the screen right now. Story is a critical element of what makes those experiences successful. It's the thing that propels the player forward and convinces them that this is an experience worth having. So these are kind of the if you can describe a game's fantasy, the action, the economy, the world, the story, then this is like the conceptual framework that you can use to describe your game to someone else. And it becomes kind of the guiding star for your own design and development process, because you can understand like, all right, what are these things supposed to be in the game? Like, what is the most important? Like, which of these elements is really central to making this game a great experience? So to help try to apply these concepts, I'm going to need some help in chat. What we are going to do is come up with a brand new video game concept, and we'll try to explore some of these areas for that new video game concept. So the first thing that I'm going to ask chat to come up with is, what is a fantasy that could underpin a video game? Like, what's an idea of a place that you could put a player in, or, you know, a role you could put a player in that would be something that they had never experienced before, or something that you would want them to experience for the first time in first person through the eyes of a character that's actually experiencing those things. So I'm going to head over to the chat and see what we come up with. Like, what would be a good fantasy to include, you know, for a potential video game. So I see some stuff coming in. I saw Dragon Slayer come in briefly. Sorry, there's a bit of a delay. That's actually a great one. So scuba diving. Somebody came up with like a scuba diver, and that is the thing that you want to experience in the first person. And swimming generally and being underwater is a great space to explore. Like Subnautica is a really great VR game that explored those themes really effectively, I think. So let's start with there. So this game, the central fantasy of the game is going to be you are a scuba diver. Now, with that fantasy in mind, like, what are the actions that could happen in such a game? Like, if you're a scuba diver, what are you going to do? Like, how are you going to spend your day? Like, what's the stuff that happens to you? What are the things that you're going to do in this scuba diver fantasy? You also see like a water dragon slayer, perhaps, like that. That's a great idea. We could combine the two, scuba diving, dragon slayer. I dig it. So I'm seeing some stuff come in, like explore underwater ruins, managing oxygen. Exactly. Like that's a fantastic idea. You have to understand like oxygen levels or pressure. You have to refill your tank, eat a fish. These are great examples of different actions that you could take within a scuba diving game. Now, I imagine you'll know what's next. So what could an economy look like? Like, how could you be rewarded for taking some of those actions? What would you do with those rewards? Like, what is a meaningful thing to, you know, get rewarded with, like, after you accomplish all of your scuba diving, dragon slaying tasks? So you could, find exotic fish. That's another good action. But, there's things like you could, there we go. Seashell economy was the first one I saw. Scroll up. You could find ancient artifacts, right? You could upgrade your tools. You could sell treasure that you find under the ocean. Y'all are doing great. I think there are some game designers here in the chat today. So that's a little bit about the economy. And in the interest of time, like, we won't go all the way maybe up the stack, but you can imagine for the world, one of the things that Subnautica does really well is it imagines a planet that's completely covered by ocean. So swimming and underwater stuff is happening all the time. Like, you barely are ever above the water. And that creates a world where swimming and survival under the water really becomes a central theme of the game, and really provides a different type of experience for the player. And the story could be anything from, you are an underwater dragon slayer and you need to find a dragon somewhere and defeat it with the tools and the other stuff that you can buy with your seashell dollars, or whatever the economic system happens to be in the game. So now we start to have like a design document, a way that we can understand how our game is going to work. And now finally, we can start to talk about why it's a stack and why we have arranged these things the way that we have. And the reason for this being a stack is because these items are sort of arranged in order of things that are easy to change down to things that are very, very hard to change. So now imagine that instead of the fantasy of scuba diving, of swimming underwater, existing underwater, we replace that with, you're a bird, right? Or you are, you're an angel soaring above the clouds. Well, that just destroys everything else, right? Because, the actions that you are going to take are completely different. The economic systems are completely different. The world setting no longer makes sense. And the story is probably also going to be incredibly difficult. Whereas some of the other elements higher up the stack are pretty malleable and they can change to serve the other items that are beneath it. So one of the great stories that I've heard about this is in the early days of video game development, there was a team going through a process of creating a game that was like a top-down shooter, like a Galaga or Raiden type like arcade game, where you're flying a spaceship around Earth and you're blasting these alien spaceships. And the people who are kind of creating the story and the world around this game were like, okay, this is happening like pretty high up above the Earth. So we're going to need clouds. We need clouds to like filter across and float above and underneath the player's spaceship. And given the technology restrictions that were available to the developers at the time, the developers took a couple days. They tried a few things out and they were like, okay, you can have clouds, but they have to be green. Because of just bizarre limitations of the technology platform that they were targeting at the time. And then the designers were like, well, clouds aren't green. This is Earth. Like, this doesn't make any sense. But then they were like, well, maybe the aliens attacked Earth with chemical weapons. And now there's these clouds of green gas that are everywhere. And just by kind of thinking and flipping the way that they thought about the story, they could make these other elements of the world and the action work. So as you're kind of going through and, designing a game, having a sense of like what kind of changes are, expensive to make and what kind of changes are a little cheaper and a little more flexible, get to be really important concepts to understand as you're, making those tough choices. And when we applied these ideas to TulioQuest, we had to think about like, all right, where is this game really anchored? Like, what's most important about this experience? And where we came to was it was really about the action, the experience of encountering a puzzle that required applying technical skill, entering, writing some code to solve that puzzle, and that loop of actually executing the code tasks. That action was much more important than anything else in the game. And with limited resources, initially just me, and later other intrepid souls that have joined the team have been a huge boon to getting the game to where it is today, we still have to apply that same focus and keep in mind, like, all right, what is really most important, and make some hard decisions and trade-offs based on those things that we have to deliver. So when we did that thought exercise for TulioQuest, the things that became important were content. So we needed lots of different types of challenges that you could encounter in the game. We wanted to be able to teach things like version control to Python development to everything in between. So the ability to teach lots of different concepts is super important. And because content was so important, content authoring was also something that was really important. So we had to invest in tools to actually create, a breadth of content within the game. Because if we just had, 6 or 7 objectives, that really wouldn't work. So those are some areas where we had to invest. The other thing that this really drove was the reason why TulioQuest is a PC game that runs on your desktop rather than a website. Or a web application that you visit in the browser, because in order to teach people how to use the tools of software development, like how to use commands from the terminal, or check that you have a local development environment set up, and help guide people through that process, our validation code really needed to be running on the computer of the developer. So that was one of the reasons why TulioQuest is a PC game, and we'll talk a little bit about the technology here in a minute. And we also knew that what was important was the narrative and level design of the content. Like, the core reason why TulioQuest worked for education and technical instruction was the carrots that we were able to provide of narrative. Like, there's a locked door, and all of us just have an instinct to want to be able to get past that locked door to the next thing. Just being able to put the player in 2D space and lay a path out in front of them where they understand, like, oh, if I keep going, then there's another thing for me to do over here. There's another chest for me to unlock over there. And just making that change, compelled players to experience way more of the game and do way more of the tutorial content than they did when we were just a browser-based tutorial website. So these are the things that we had to focus on that really mattered. And then like some of the things that ended up mattering a little less, or the things that we didn't invest as much time in. This one really broke my heart, which is we haven't focused as much on like world building, storytelling, exposition. I assure you, I have, probably 50 pages of Google Docs of the lore and history of the TullioQuest universe that who knows if anybody will ever experience it. But at the end of the day, it's just not as important as getting that educational content out there. One day I hope to incorporate it, but we'll see how that goes. The XP and the loot economy were important, like they were part of the motivation. But what we saw after we deployed the first version of TullioQuest is like what really got people going was progression. They saw a corridor with locked doors, and they saw places and nooks and crannies to explore. And in our user testing, we saw like that was really the thing that drove people to action. So how many points you scored and the loot that you acquire is fun. And I think people have really liked that, but it hasn't driven behavior in the same way that progression does. And also like RPG staples like combat and the vendors and stuff like that. Those are things that like we want to incorporate in time, and I think that eventually we will. But again, like it turns out that they weren't necessary to make the experience what it is. So, as you're thinking about taking on a game project, number one, my advice to you would be to keep it small, to try to focus on one nugget of something excellent in the experience of a game, and then focus on building that. Like Doodle Jump is a incredibly successful game, and it has like 2 buttons and probably the simplest controls you could imagine. So just try to find that one nugget of something cool, whether it's a story or an element of world building or an economic system that you think is really cool. Hone in on that one thing and decide where your experience is anchored and build around that. Because building a game is less like building a car than it is like packing a snowball. So you start with something very solid at the core, and then you can kind of pack things around it. And then eventually you end up with an experience that's pretty great. So what I'll close with is just a quick look inside the technology stack of TullioQuest in case you're interested in trying this yourself with web development skills, which if you're like me, I didn't go to college and learn how to use Unity, although I did evaluate it for the TullioQuest project. But the web development skill set I had meant that I could be more productive if I used those skills in building the game. Also, the fact that we lean so heavily on rich media and content is a great reason to use HTML and CSS in the presentation of the content, because we can have hyperlinks, we can create user interface with HTML and CSS, specifically using React, which ends up being a great advantage. So as we were kind of making these early decisions, we knew we wanted to be on the desktop. Web technology was going to be useful across a variety of vectors. And we knew that, our game would be highly reliant on user interface. So having a high-level UI library like React was going to be really useful to us as well. And then the way that TullioQuest kind of works together is in the game window. It's an Electron desktop web application. And to define Electron a little better, some folks may have run into it before, but it's a desktop app framework that lets you package HTML, CSS, and JavaScript and ship it as a desktop application. So Visual Studio Code, the Slack desktop app, the Discord desktop app, all of those use Electron as the way to deliver that experience to the desktop. And that's what we use with TullioQuest as well. And then within the game window, which is an HTML page, we have a WebGL canvas, which kind of sits behind everything. And that's where like the more gamey bits happen. We render like the player movement and sprites and like handle collisions and that sort of thing within a WebGL canvas. And those interactions are managed by a library called Phaser, which provides lots of great high-level APIs for doing animation, for rendering tile maps to the screen. We also use an open source tile map editor called Tiled to actually construct all the levels within TullioQuest. It's an open source tool, which is great, and exports like map data as a JSON file that we can then work with in JavaScript. So it ended up being a really nice choice for us. And then on top of that WebGL canvas, where all the phaser magic is happening, is a React web application. So everything that you're interacting with and clicking on is driven by React. And that's a major benefit that we have over, say, Unity, where in my experience and frankly, uneducated opinion, I found creating UI in Unity and in like game engines to actually be kind of tricky in comparison to building those same things with HTML and CSS and JavaScript. So the ability to create user interface using web technologies actually ends up being an awesome technology choice for those reasons. So we talked about some of the pros and cons. The couple ones that we maybe didn't get to is as we look to have more developers contribute to ToolioQuest, and that's something that we're going to be very interested in the near future, choosing web technologies makes it easier for more people to contribute. Fewer people maybe know about Lua or Unity than know about HTML, CSS, and JavaScript. So it ends up broadening the community of people who can contribute to the project. And then with Electron specifically, the fact that we have access to the whole universe of Node.js packages and the NPM ecosystem has been just a huge boon. Like, there are fewer and fewer problems these days that you can't solve with like NPM-I. So the access to the open source ecosystem of JavaScript has been a tremendous shot in the arm for our project. Some of the cons, obviously, like the performance of the game, especially on lower end hardware, is not yet where we want it to be. So like Electron itself is pretty heavy. And then browser-based game engines are just not as performant as like their native counterparts, and that's just one of the trade-offs that you make working with web technologies. The other things that you'll notice is like the tooling for the gamey stuff, like for level design and sort of dragging and dropping elements into a game environment. If you use tools like Unity or Game Maker Studio or other types of things, like you might be used to higher level tools that as a rule generally don't exist if you're doing game development for the web. And then this is probably the worst part of going to the desktop, which is packaging and distribution. So the ToolioQuest web app is something that we have to sort of package up as an Electron application and code sign and ship to everybody who plays the game because we wanted to distribute it independently. And it turns out that that's a bear. And it's among the gotchas. I'll maybe start with that one first because even though it's down at the bottom, is like if you're distributing a desktop web application, doing it on your own and distributing independently outside the app stores is a massive undertaking and has shortened my life by at least 3 years. So if it's something that you can avoid, I would recommend doing it. Just kneeling to your corporate overlords and distributing through the app stores will probably save you a lot of time, unless it's a deal breaker for the experience you want to create. Some other things to be aware of, like the Electron userland packagers, which actually create those installable applications, are great. They actually are super slick in many ways. But if you have to kind of deviate from the happy path that they've created, it ends up being a little tricky. So we use lower level packaging tools and NPM scripts to build our distributable binaries that we actually ship to all of you. Another thing that you'll encounter if you're a React developer, you're probably used to using tools like Create React App, where there's like a local web server running that loads up your application over HTTP. That is great, and you can actually do that with Electron development as well, but there are subtle differences between loading resources from the file system via, versus HTTP. So always best to determine that your application also works like after you package it all up and there's not a web server running in the background. Also, just file system access and platform permissions across platforms. Actually, there's a bug we're working on right now. We had somebody who was participating in ToolioQuest and they had installed Git on their system, but we were not, like the game client wasn't able to detect it on their system path. So those issues continue to be tricky. Like we've invested a lot of hours in ironing those out, but those platform-specific gotchas, it's more relevant for ToolioQuest than it would be for other games, but definitely something to be aware of. So with that, I'm going to try to wrap it up and leave some time for questions and a little bit of a break before the next presentation. But I appreciate your time. I love talking about this stuff. I'm learning about it all the time. And I just have the privilege of being able to work on something that I really love and enjoy and want other people to love and enjoy it as well. And I hope that even if it's not games, that all of you, as you're starting your careers in software development, are working towards that goal to work on something that you love, that you are able to pour your heart into and make people happy. And hopefully you will be able to do that. So thank you very much. And let's see if we have any questions.
Well, thank you so much for such an amazing session on how we can get started designing worlds for our own games. And I have to admit, one of the games that touched me the most about history in general was Assassin's Creed. So if it wasn't thanks to the game, I wouldn't be able to know so much about like Italy and so many other things. And I'm really excited we get to have a game for developers to learn how to code.
Absolutely.
We have some questions coming in from chat, so let's go through them. Dominic is asking, how do you think of adding Konami codes in the game? What's your opinion for like these kind of Easter eggs in a game?
I'm a big fan of Easter eggs. So there is an Easter egg in there for GitHub University. So there's one hint in the document that's been kind of going around. But the hint to find the Easter egg for GitHub University is hit the nail on the head. And that's all that I will say on that topic. So obviously, I'm a big fan of Easter eggs. Like the primary thing that they do is they're just an opportunity to delight users. Where like with the Konami code specifically, savvy players will always try it first, right? Just to see if it does anything. And in Twilio Quest, like up until I think it still works. The Konami code, I think, still does something in Twilio Quest. We might have taken it out. I can't confirm or deny, but for a long time we still had it. But the role of those Easter eggs is just to be a delightful surprise, and I think that it's great to include those.
Yeah, and it's great for all of those folks who want to have all the achievements and try to get 100% in everything that they do. Cool. So we have a question from Soul Reefer. What do you think about open source games or games that are F2P but that have monetizations?
Yeah, I like the idea of open source games. There's a few that I've played that have been actually pretty good. So one is like Battle for Westnoth. It's like almost like a Fire Emblem style strategy game, which is pretty great, and it's GPL licensed, I believe. So there's definitely some examples of those things working well. With Twilio Quest, it's not yet open source, like the engine itself is not. We're working on actually open sourcing the content. One of the things that we're really excited about is also and we'll maybe get to this later too, I don't know, but like we are opening up our content authoring tools so that anyone in the world can make content and missions for Twilio Quest, which we hope to do early in the new year. So we'll be open sourcing large parts of what we're doing. The authoring tools, the content itself, like the JavaScript mission, we will plan to open source. So I think like those bits are really important. It can help like build a community. With regard to monetization, I'm not really an expert because for Twilio, our game is about creating a larger market of developers. It's a developer evangelism exercise for us. Like we believe that if more people have access to developer skills and we're just creating a larger and more vibrant community, like that is going to help Twilio's business. We're Twilio content you can definitely do within the game, but it's entirely possible that you'll play Twilio Quest and never do Twilio content. So because like we view it as kind of a marketing exercise, it's less about monetization for us. So we might have to ask somebody who needs to monetize their game for, more insight on that.
Yeah, and I'm just thinking as a student who wants to get involved with game development, having all these resources for free or already available can be useful to get started with. I don't know, like just don't start from scratch. You have already some resources available. And
Absolutely.
if you like to create video games and at the same time teach others, it's a great way to get started as well.
Yeah, totally. So like, we plan, I'm hoping that by like end of January-ish, early in the new year, we'll have the Twilio Quest content authoring tools out there. And those are great places to start. Like, lots of people who make games like got started with like modding. So you can, create mods for Minecraft to create like an overpowered pixel sword. And that can start to get you familiar with some of the core technical things that you need to do to participate in game development. And I hope like the Twilio Quest tools hopefully will provide a similar on-ramp. So I think that'll be great.
Yeah. We have another question from Platish. A lot of what I've heard about before about game design emphasizes a focus on primary gameplay loop, 30 seconds of gameplay, then repeat across the game. How does this fit in the stack? Action? Is it in action? Is it in economy?
I think those loops, this actually came up in the session where I learned about the game design stack for the first time. And I think those loops exist in different places within the stack. So in a game that's more anchored in economy, the loop is, you're creating a resource, you're selling the resource for a profit that you then reinvest like back into your infrastructure to create more resources. So that gameplay loop is centered in economy. But there are other loops like, in Destiny, you go on a raid, you shoot a bunch of aliens, you get a new gun, then you go on another raid and you shoot a bunch of aliens, you get a new gun or what have you. And that loop is sort of anchored in action. So I think like that is like a tactical means of thinking about like how you implement these. So if the game design stack is a strategy, I think those loops are the tactics. Like that's how you implement the strategy.
Super interesting. And just trying to know where you will put the cycles so that you can get people to repeat the actions that you want to repeat them the most, right?
Mm-hmm. Yeah, it's true. And again, in Twilio Quest, we cheat a little bit in that we really want people to experience the content. And it's sort of the loop is coming in and we want people to experience as much content as possible and learn as much as they can. But we're like less concerned about like, and then we need you to come back and do it again. So maybe single player, there are kind of different concerns depending on the type of experience you want to create.
Of course. And now, unfortunately, we don't have that much time for questions. So we're going to go through the last one. I guess you're going to be in chat afterwards, trying to solve some of the questions. And last question that we have is, did you ever felt overwhelmed by the amount of knowledge someone told you needed to know? If yes, how did you overcome that?
Yeah, I definitely have and sort of continue to be overwhelmed by the amount you need to do or an amount you need to know to be productive. And I've been a developer for about 16, 17 years, professionally, and it still happens like all the time. There's a million things that I wish I could do in Twilio Quest myself that I at this point don't yet know how to do. But I think like the best thing to fall back on is the advice that we got yesterday of that knowledge is acquired and it's not innate. Know that like any problem that's big and hairy is solvable with effort and time. And you are able to do that. Like, as long as you kind of focus on the fact that like, all right, there's lots of things that I don't know right now, but I know that I have the ability to acquire that knowledge. I'm brave enough to ask for help when I need it. And I will just, eat the elephant one bite at a time. So just trying to remember that like, even something big like a video game is something that you can do, but you just have to kind of go one step at a time, create something small and like pack the snowball. So start with something small and then just keep going.
Well, thank you so much for those amazing responses to the questions. And if there's any place students can follow you up and know where you're currently working on, can you let us know right now?
Yeah, absolutely. Feel free to give a follow on Twitter. I'm at Kevin Winnery. We announce stuff like I will retweet it, obviously, but we announce stuff for the game, like the authoring tools and other stuff that we're up to at Twilio Quest on Twitter. There's also a newsletter you can sign up for at twilio.com/quest. And we push out all the new stuff through that newsletter as well. So yeah, would love to connect any of those. And then also we do have the Twilio Quest Slack team, which is also linked from twilio.com/quest if you want to hang out with other people that are playing the game. There's also a Discord as well that people can hang out on if they so choose.
That's amazing. So there's a lot of ways to reach out
Lots
to
of ways.
Kevin.
Yes.
Thank you so much for joining and taking the time to tell us about the game stack that you're using for Twilio Quest. If you like the talk, you can leave sparkles in chat for Kevin, I know he will appreciate them, and
You
you'll be around in chat for responding any questions that you have. And thank you so much. Now, moving forward, for those of you not yet playing Chile Quest and Operation University, this is your time to win some extra swag. So you can also make your first pull request and start contributing to open source development. The more that you play, the more chances you'll have to win. Make sure to add the code word GHUniversity 2020 when joining to get added to the leaderboard and be entered in the raffle. That's all written down below in the instructions as well. Thank you, Kevin, for joining us today and answering all of these questions. And now we will have a 60-second intermission, and we'll be right back with Yash to continue with the next sessions that we'll have here at GitHub University. Have a good one, everyone. See you in 60 seconds. Hey everyone, we're back on the stream. Great to see you all that stood here with us. Josh, we're moving forward for the next session. We had a great session with Kevin, and now we're moving with Lika. Josh, can you tell us more about Lika and the next session?
Definitely. Next, we'll be hearing from our favorite people, the former Campus Experts Program Manager at GitHub Education, Lika Boone. She is now working with MongoDB as a Program Manager for academia.
Now, Lika, I know she has been in Mongo now, but she'll always feel like part of the GitHub Education team. She had such an amazing impact in the Campus Expert program, and everything that she did here at the GitHub Education team.
Yes, and joining her to talk about getting started with MongoDB is the principal developer advocate, Michael Lin. Michael is a developer, podcast host, instructor, conference speaker, and a passionate developer advocate for the MongoDB's data platform. He focuses on MongoDBs for startup and the mobile application developers. Let's have a huge warm welcome for Michael and Lika.
Thank you so much.
That made me all emotional. That was so nice. So I think we should get started, right? It's time.
Yeah, let's do it.
Yeah. Okay, good. Well, hi everyone. Thank you all for joining tonight or today. Matters where you are. I think I'm speaking for the both of us if I say that we're very excited to be here. And MongoDB is a proud partner of the GitHub Student Developer Pack. And in this session, pardon me, I will dive a bit deeper into the MongoDB offer in the pack. And after that, Mike will share everything about MongoDB and he will take you on the journey of MongoDB Atlas, which is going to be lots of fun. So before we start, I quickly want to share a bit about me, or at least what's still left, because I had this wonderful introduction already. So my name is Lieke, and I am based in the Netherlands, and I work remotely from here. And I live here with my partner and my dog. It's tons of fun. And I am the program manager academia at MongoDB. I joined there in January this year. And before that, as you know, I worked at GitHub most of the time on the GitHub education team, where I also run the GitHub Campus Expert program. And I thought it was nice to actually show this picture. This was last year, November, at GitHub Univers. You might see some familiar faces. And some of these experts, well, plenty we have, but I invited some of these experts last year to join us in San Francisco. And it was really nice so they could connect, so we could meet each other. Those really awesome times where we could still travel and go to conferences and hang out. But yeah, it feels very special actually to be here today and to be part of this amazing event, albeit virtual. So I'm really grateful for that. And well, my passion is in education and to support students and teachers. And that's also what brought me at MongoDB. So I want to dive a bit deeper into MongoDB for academia. This is part of the Emergent Developer Relations team, and the team has a goal, and that's to inspire the next generation of MongoDB users and to make them successful in their work. And MongoDB for academia also wants to create the best learning experiences for students, and we want to make sure that we offer all the resources that we can to make students successful in their future careers. So we actually focus on two target audiences. So we have educators and we have a program for students. And I want to highlight our educators program as well, because there might be professors in the audience or teaching assistants, or maybe you have a teacher and you really want them to teach MongoDB. So if you're curious about our offer, you can go to educators.mongodb.com. This offer is for universities, schools, boot camps, or online courses, so it's very broad. And what we offer at the moment is content support. That means that we provide new course materials, or if you're already teaching MongoDB, we also help you with reviewing the content, going through it, make suggestions, just to make sure that everything is up to date. And besides that, we give you access, on-demand access to MongoDB University. This means you can actually follow all of the courses that MongoDB University offers in your own pace and your own time. Because normally you have to sign up and there's a date and there's a time. And with the on-demand access, this is actually lifted. So that's really nice. You can share this license with other students or with your students, sorry. And you can also follow the progress of the students. And lastly, which is also really cool, is that we have an academia community. This is a private group on the community forums, and we invite you there, and you can collaborate, share tips, ask us questions, and hopefully get inspired. And then obviously we have the students, and we joined the GitHub Student Developer Pack in February. And our offer is actually the biggest offer that we have at the moment. And what it means is that if you join the GitHub Student Developer Pack and you sign up for the MongoDB offer, you get access to MongoDB Compass. That's the GUI from MongoDB. And it gives you a better understanding of your data without the need to really know the MongoDB query syntax. So that's actually pretty nice. We also give on-demand access to students. And on top of that, we offer free certification. So you can follow a learning path, for example, the developer one or the database administrator one. And once you're completed it, you can send me an email, and then I give you a code, and with that code, you can register for the exam for free. And then we give you access to MongoDB Atlas. And MongoDB Atlas is our global cloud database service for modern applications. You can actually set up a free tier, which already covers quite a lot if you have maybe a simple project. But if you want to scale, we give you $200 in Atlas credits. Mike will also dive deeper into Compass and MongoDB Atlas, so don't worry about it. And if you're curious about the offer, you can go to students.mongodb.com. And what's obviously nice is that we have a lot of students who already used our offer in the GitHub Student Developer Pack. And I just want to highlight a couple of them. So if you go to the student gallery on GitHub Education, you actually find tons of projects on there. And some of them, or a lot of them, have MongoDB as well. You can, for example, build a blogging platform, as you see here on the left, or a strategy game, a real-time strategy game. That's also very nice. Or you can go for a multiplayer online game like Pictionary, or you could do something completely different as the last one, and that's a web application that actually provides crucial information in times of crisis, medical crisis, like being in a pandemic. So if there's anything that you want to see, go there, and you find tons of nice projects that are made with MongoDB and the GitHub Student Developer Pack. And we know that MongoDB is actually becoming more and more popular with students, and that a lot of students are excited about MongoDB and are building projects with MongoDB. And that's also something that kind of inspired us to launch our MongoDB Student Spotlight program in the beginning of 2021. It's like, it feels like so long, but it's almost here. And what we will be doing is we'll have a page for students where we not only highlight the project, but also the student. So it's for students by students, and we hope by showing these MongoDB projects and a bit of the background of the students to also inspire others to build with MongoDB. And maybe we can inspire educators with some assignments that they can create. So we're very, very excited about that. And we'll also be launching new course content for educators this quarter. So that's already soon. And it will be a course about why MongoDB and why NoSQL or NoSQL. So that's actually something we noticed that a lot of teachers would like to have. So we're also very excited to be launching this quarter. Those are some short-term features. We obviously have tons on the roadmap for next year. So I would say keep an eye on developer.mongodb.com/academia. It's a long URL, but it's a great website to go to. And if you go there once in a while, just to stay updated of everything that will be launching soon. That's kind of what I wanted to share with you. I know it's not a lot of time, and I look forward to chatting with you later or on Twitter, everywhere. If you have any suggestions or questions, you can email me at academia@mongodb.com, or please go to the forum, ask your question there. I'm also on there regularly, so you can go to community.mongodb.com. And with that, I am handing it over to Mike, who will show you all the awesome things about MongoDB and MongoDB Atlas. So thank you.
So much, Lika. It's great to be here. Terrific. I am also very excited and inspired. There's so much going on at MongoDB. Who am I? I am Mike Lin. I am a developer advocate at MongoDB. I'm based in Philadelphia, just outside of Philadelphia on the eastern coast of the United States. And I've been with MongoDB just about 5 years, having a blast, working on all sorts of amazing projects. Looking forward to working with you. So I also host, along with Nick Raboy, the MongoDB podcast. And that's where we cover all sorts of great topics related to software development, data, and anything related to MongoDB. So check that out at mongodb.com/podcast. I hope you can take a listen and enjoy that. And Leek already mentioned this, but check out the community. There's forums where you can interact with other users. I'm in there every day, looking for questions, looking to interact with folks like yourself. So check that out. So what is MongoDB? Let's get into it. MongoDB is a document-oriented database, and I'm going to cover a little bit more about that in detail. But when I say document-oriented, what does that mean? It is developer-friendly. Every decision that is made about how to modify or enhance MongoDB is made with the developer in mind. And you're going to see some of the ways that that comes to the front. It's highly scalable and available. And I'll talk a little bit more about that, explain it, and then I'll go into a demo. So I want to get right into it. What is this giant mess? What is this? It's an entity relationship diagram. And what you're seeing there is all those little boxes are tables. This is what you would see in a legacy or a relational database management system. Some of you may be familiar with this. This is how you develop the schema for a relational database management system. MongoDB is a little different. It is documents versus tables. So we use a little bit different terminology, and I think it helps to draw the lines, the comparisons between RDBMS and MongoDB, or a document database. We still call things databases, but where you would call something in a table in a database, we have collections. So we have collections of documents, and where you would have a row in a table, we call that a document. So I'm going to show you what these documents look like, but just know that you also are able to, with MongoDB, support joining information from multiple collections of data. You have the ability to create views as you would in a traditional database, and you have the ability to support ACID transactions. That's very important for highly scalable applications. This is what it looks like. On the left, you have a couple of tables for an application designed for a relational database management system. And it looks like from the data shown here that it's an application that deals with people and their cars. Well, we're representing data on the left in tables, rows and columns in tables. We can represent that very same information in MongoDB using a document, and that's exactly what you see there. That is a JSON document, JavaScript Object Notation. That's basically keys and values. The keys are always going to be strings, and the values, they can be strings, yes, but they can also be pretty interesting structures of data, like sub-documents or arrays of documents. And that's what we're representing there in the cars field. It is also developer-friendly in that you can develop applications to modify and maintain MongoDB data in virtually any modern framework or language that you're used to using. JavaScript, Node.js, C, C++, C#, Go, Ruby, Scala, R, all of these are supported through the rich network of MongoDB drivers. We also have some tools that will help you as a developer. So MongoDB Compass is the user interface for MongoDB. You install that on your laptop or desktop, and you can use it to connect to MongoDB and visualize your data, as well as edit or update documents right in your database. We have the MongoDB shell, which gives you command line access. So if you want to log in with a shell and you're comfortable issuing command line commands, then you can use MongoDB shell. And lastly, something relatively new, we have a MongoDB extension for VS Code. So if you're a VS Code user, I'm sure there's plenty of you out there. You can install an extension and modify and view your MongoDB databases right inside VS Code. Let's talk about MongoDB Atlas. Now, Lika mentioned it. It is our database as a service, which means it is online, it's in the cloud, it's highly available, it's free forever for the M0 sized instance. What is that? Well, I'm going to get to the different tier sizes in just a moment, but just know that you can log into MongoDB Atlas, create your user ID, and launch a cluster without even pulling out a credit card. And you can run any kind of data, any kind of application against that. The only restriction is in the amount of data that you store and the availability of the CPU and RAM. It's going to be shared instance on the lower M0 tier. I'll talk a little bit more about that shortly. But there's also built-in security. There's backup and restore. There's auto scalability between the tier sizes. If you're not sure, you can set a configuration setting to automatically scale between different tiers. And these are the available tiers that we have. We actually have some that didn't fit on there. There's an M700 with, just tons and tons of RAM and storage available to you. I think it's best if we jump into a demo. What do you think? Just change my tab here. I hope that's large enough. Lika, can you see that okay? All right, so I'm logged into MongoDB Atlas, and I got there by going to cloud.mongodb.com. And you'll have to register and create a user ID. Once you do, it will walk you through a wizard. Your first interaction with MongoDB Atlas is going to be to create your first cluster. It's going to look something like this. Create new cluster. Now, the first section of information that we could fill out is going to allow you to scale your database across the globe. Most users right out of the box are not going to be doing this. They're just going to be accepting the default and having a single cluster in one data center somewhere in the world. So we'll skip the global cluster configuration for the time being, and you can do that as well for your first cluster. The next question is about the cloud provider. What is a cloud provider? Well, these are the services that we as MongoDB leverage to launch, deploy, and maintain your MongoDB database based on all of the configuration preferences that you have. So MongoDB Atlas is an application that lives above the cloud provider. You go to cloud.mongodb.com and you're running Atlas as an application in your browser. And we deploy the MongoDB instances into AWS, Google Cloud, or Azure based on your preferences, based on your configuration settings. Today, I'll deploy a new cluster into an AWS environment. And the next thing I want to do is change or set the location where that database lives. And I want to set it right now because I'm the only one developing against it. I probably want it to be close to where I am. And as I mentioned, I'm in Philadelphia, so I'm going to select North Virginia. That also has a free tier available, so that'll work for us. The next questions are about the tier size. Now, I mentioned we have an M0 free sandbox-sized instance. You can certainly select that as your first cluster. I've already done that, and it's important to note that you can only have one M0-sized sandbox instance per project. You can have multiple projects, but you can only have one M0 in a project. I've already done that, so I can't select it. So I'll select something a little larger just to show you the configuration settings and available options. Notice I'm selecting M30, and as I change to an M40, your per hour charge is going to go up. So you're paying only for what you use based on the tier size. So an M20, for example, is going to give you about a 20-cent per hour cost. When I select a larger instance, something more suitable for a production application, for example, I can see that I'm going to get 8 gigabytes of RAM available, 40 gigabytes of storage, and I can change that. I can add storage, and again, the per hour charge is going to change based on what I select for my storage. And here, if I'm not sure about, maybe I'm deploying this instance and I know that I'm going to get a bunch of users right out of the gate, but I don't know how many, I might want to select auto scalability. That's going to give us the ability to deploy on an M30, and then based on whether or not those users show up and start hammering your database or your application, it will then deploy a larger size instance to meet the necessary demands. Very powerful, especially for a startup or maybe a student with a project that you've got for a final project, and you want to be able to make sure that all of the students can get in and access the data. That is auto scalability, very powerful. Moving on, we have additional settings around backup and restore. Pretty straightforward. If you want to make sure your data is available in the event of a catastrophe, you want to back that data up, of course. And then you could change the cluster name. From there, you would just hit create cluster, and it usually takes about 7 minutes to deploy a cluster. I've already done that, so sort of like a cooking show. I've already deployed my sandbox instance and even a larger instance, so I can show you what these things are all about. Once you deploy your cluster, the next 2 steps are going to be for you to give people access to it. You want to be able to have people log in, or your application log in and access the data. That's going to be done by creating a user in the database. Sorry, I might have timed out. My credentials have timed out. Sorry about that. So click the database access, and you're going to want to create a user. That's going to give your application a user ID and a password that you can use to log in. The simplest way is with a password, but you can also use certificate-based if you have security concerns, or you can even, if you're an AWS user and you're familiar with IAM user credentials, you can use an IAM access credential. For the time being, I'll just add another one for Lika, because she's going to log in and start modifying our database. And from there, I'm going to give her the type of access I want. She's going to write an application that's going to have read and write to any database. And from there, you also can grant access to this user to the data lake. I'll leave the data lake for another talk, but this is really important, a temporary user. Maybe Lika only needs access for a day or a week or maybe 6 hours. You can set this setting, and her user ID will be removed after that period of time. I'll go ahead and add Lika, and that way she'll have access. While that's deploying to the 3-node cluster, let's jump back over and, or actually, let's make sure that we have network access. So we've added a user. Now we want to make sure that we have access over the network, and that's essentially poking a hole in the firewall for my specific IP address, which I've already done. You're going to want to make sure that you do this for your IP address. You can, if you wish, open access from anywhere, but just know that that's a bit of a security concern. That means that anybody from anywhere, any IP address on the internet, can get access to the cluster, but they'll still have to have a user ID and password. So be careful with that. Make sure you add your IP address or the IP address of the application that's going to be issuing commands to your cluster. Once you have your user and your network, you're pretty much good to go. So if we come back to our cluster screen, I'm going to see the cluster. We get to see what's going on in terms of operations and the logical size. And I can begin to actually look at the metrics of my applications that are accessing this data. Now, I just deployed this earlier, so there's not a whole lot going on, but I do see that there are 3 nodes in this cluster. That's how we achieve high availability. So if this primary were to go down, one of these 2 other secondaries is going to pick up and become the primary until this primary comes back online. That is what we call high availability. So we've kind of covered scalability in that we can change between any tier. We can even do that automatically. And we've covered availability. Let's look at the actual data. Now, I deployed my free tier instance, and I called that GHU for GitHub Univers. And let's take a look at deploying a sample data set. So you may not know much about documents or a document database, what that looks like, but MongoDB gives you the ability to deploy these sample data sets. And they're fantastic because they give you really great examples of how document databases are laid out. I've already done that. It takes about 5 minutes to deploy. So let's skip that and go right into our collections. And we can see that there are a number of databases in my data, in my cluster, labeled sample underscore. These are the sample databases, obviously. One really cool one is this sample Airbnb database. And this contains all the data that you might think that you would see in the Airbnb application. So it's describing the listing URL for Airbnb and what type of listing it is. And notice right in Atlas, in the console, I have the ability to edit the data. So at any point in time, I can change this data and commit my changes. I can even insert new records. So if I slide over here, I can insert a new document and type the entire data for that document. So really powerful control, great visibility. And how are we doing on time? So we've got about 9 minutes left. I think we're good. So from here, what I'd like to show you is how to connect to this data. Let's say you're going to write an application, or maybe you want to use MongoDB Compass to get visibility to that data, and you want to see what it looks like, maybe even edit it right from within. So we're going to jump over to MongoDB Compass. As I mentioned, this is a tool that you download and install, and that's available from the MongoDB website, MongoDB Compass. And what you're going to do is you're going to provide a connection string. So I'm going to say connect to, and it's going to prompt me for the location, the URI of the cluster that I want to modify and maintain in Compass. Now, while this is coming up, here's the prompt for the connection string. Where do I get that? Oh my goodness. Okay, so I'm going to come back to Atlas, and I'm going to click the connect button, and then I'm going to select that I want to connect to my cluster with MongoDB Compass. And this is going to give me the URI here. Copy this connection string, then open MongoDB Compass. So make sure you have Compass installed first, open Compass, and go to that connect screen, copy this connection string, and then jump back over to Compass, and you can paste that in, and then make sure you type the user ID and password that you just created. Lika just created one, and this is super secure. I hit connect, and there we go. So now we have 2 instances open, but that's okay. Make this a little bigger so we can see it. So here, just as we saw in Atlas, we see all of our databases. And if we kind of drill into the sample Airbnb and click the listings and reviews collection, I see the very same view that I saw inside Atlas. Pretty cool. Now, one really great thing is we have the ability to analyze the schema of our data. And what that's going to do is it's going to look at all of the documents inside our collection, inside our database, and it's going to try and determine the best possible way to display the data for you. So for example, if I look at the data, I see that the accommodates field, it's an integer 32 field, and it's got a number of different types of values. And Compass has said, you know, the best way to display this range data is going to be in a bar chart. So here we have a bar chart, and I can see that 37% of my data in this database has the number 2 in the accommodates field. So really intuitive way. But this is one of my favorite things. If I open the address, where do we go? Here we go. If I open the address field, we can see that country, there's a range of different values. And if we come down to location, what is this? It's a map. The map is displaying pins on a map. That's pretty cool because what it's done is it's interrogated this field and it said, okay, I see an array of latitude and longitude values, and humans can read those for sure, but you may not understand what 7.999484, 49 dot something or other is, and it does. So MongoDB Compass knows that that is a geolocation, a set of geolocation coordinates, and it says humans really would love to see that in a map. So it's going to put pins on a map for you, and there's that data. So you can actually hover over each one. Now, why Airbnb has has a listing in the middle of the South Pacific Ocean, I don't know, but it does. So yeah, again, this is sample data. So that is MongoDB Compass. As I mentioned before, you have the ability in the document section to edit. You can insert. You can modify each instance. Here's an embedded set of documents. You can review those. Got this set really huge, so it's displaying kind of funny. Yeah, so that's the sample data. Looking at it in the MongoDB Compass interface, that is really where I think I wanted to cover. I think we're good on time, so I think what I'd like to do is jump back to the presentation, make sure we cover off the rest. So we launched a cluster. We took a look at the sample data. We added a user. We added a firewall entry to access over the network. And we looked at MongoDB Compass. So I hope you found that useful. I hope you were inspired to jump into MongoDB Atlas, create a cluster on your own. Again, you can start for free. Don't forget to visit mongodb.com/podcast. I would love to have you as a listener. If you have the time, take a listen to some of the episodes. And if you enjoy what you hear, leave us a review. That would be fantastic. Visit us in the community. I'm always waiting for folks to ask questions and interact with the rest of the community. And as Lika mentioned, visit us at students.mongodb.com to get your $200 Atlas credit. Sign in with your GitHub credentials, and you'll be good to go. That is all I have. Thank you so much for listening. Are there questions? Do we have any questions from the audience? Thank you, the C2N14. Appreciate that. Amazing first impression. Thank you so much for saying that. I hope you do come in. It looks like M. Ketzler asked a question previously in the stream rather. If you could resend that, I'd be happy to answer it.
Yeah,
Cool.
Cool. So
You're
I'll be
welcome.
taking here. So Michael, we'll be talking about all these questions a bit later over here in the stream as well. Thank you so much to both of you.
Comments or any questions
Yeah.
that I don't see?
Don't worry about that. I have a few questions on board. Like I have selected a few out of those in the whole stream.
Approximation of MongoDB. It is not MongoDB, but it tries to approximate the same API, the same type of features, and I think it gets pretty close. I think it's something like 60% of the features are covered, but it's not completely MongoDB. That's the major difference. Yes, you can host MongoDB on AWS without Atlas. Of course you can. MongoDB runs anywhere. It runs on your laptop, runs on a server, runs in every cloud provider. Of course, MongoDB Atlas will save you all of the effort around deploying those instances and managing them and securing them. But yes, you can run MongoDB anywhere.
Well, Michael, thank you so much for the presentation.
About use cases where NoSQL will be better than SQL. So yeah, it's going to be case by case basis. But what I find with NoSQL versus SQL is that NoSQL gives you a greater degree of flexibility. When I design an application for use with SQL, I am, by its very nature, forced to separate my data into tables. I have to normalize my data. The major difference with NoSQL is that I have the option to store all of the data that I'm going to access together in the very same place. So that means creating one document for a user and storing all of the prescriptions that the doctor assigned right in the very same document. We have this kind of mantra that we say when we're designing document structures and schemas in MongoDB, all of the data that will be accessed together should be stored together. And it's the very opposite in SQL, where you store it in tables that are distributed. Now, those tables can be distributed in all different places on the disk, which makes it very difficult to scale out to multiple servers horizontally. And that's a major difference with SQL. Okay. Yep, EC2. Yep, somebody's answering the question. You can absolutely install MongoDB on an EC2.
Okay. So we're back now for GitHub University. Thank you so much for both Lika and Michael for joining us today. And we have some Q&A here in chat. Michael is going to be responding while we are solving some issues that we had with Michael on live on stream. Yash, what do you think about the talk that we just had about MongoDB Atlas?
Right, I just loved it. I have used Atlas before, and actually, the way depth Michael got into was really good. Like, I had tried a few things, but this was a really in-depth talk. I just loved it. And actually, just before that, the things Lika told about the academia section, I think a lot of people are not aware of that. Actually, how great services you can use in MongoDB using the GitHub Education pack. That's really cool thing.
Yeah, and it's really cool to have these folks joining the GitHub Student Developer Pack. I think is one of the greatest tools you can have. I see a lot of folks asking about when can you use these kind of databases? How can you start using this technology? And I'm sure if you follow that podcast that Michael was talking about on his talk, for sure you can have much more information about Atlas. Also, super excited to see that Lika is still working on education, that she's doing an amazing work now, not only with educators, but also with folks that are just like students and getting to know more about the projects that they're building, promoting the projects that students are building with Atlas as well. And I think, I don't know about you, Josh, but I've been using MongoDB a couple of times now, and it's just very good to have or to know when to use a relational database and when not to use one. Just getting to know the difference between both will open your eyes on when MongoDB is a great tool and when probably, I don't know, it might not be like the best, but generally speaking, we have explored a lot around MongoDB, and it has been amazing to use Atlas and all of the tools that Michael mentioned.
Right, definitely. And when actually I use it with JavaScript, I'm just totally amazed by the way it works. Like the different stacks are really good aligned with MongoDB. That's for sure. Okay, perfect. So can we have Lika and Michael on the stream, please? Like I would love to ask them some questions.
Also, folks, if you're not aware of it, we are currently having right now a 50-minute session in the play track. You can hear from an Australian-based XR artist called Michelle Brown. Yes, you heard it right. We're having art and music being created in mixed reality. So make sure that you get some time, check that out. If you haven't done yet, we are still running Twilio quests right now on our repository. We have so many of you already joined. I think we have kind of like more than 200 people joining already and helping keep the flame of open source alive. We couldn't be more excited about seeing all the pull requests. If you haven't seen my pixel, you can find it. I think it was in the 41/35 position. You can see there's the color that you all chose for me on the Twitter poll, and we couldn't be happier to have seen what is the art that you're all creating. We've seen some folks that are working together and creating kind of like some sort of multicolor section, but we want to see more about what are you working on. Let us know in chat what are you currently doing, if you have already built something on Twilio Quest. Also, if you are getting stuck with Twilio Quest, let us know. We want to learn anything or any problems that you're having on the game. And Josh, right now we are reaching out the last part of this first session of GitHub University for the second day. What do you think about the sessions that we have had in the last, I think, 2 hours and a half?
Right. So in the last 2 hours and a half, we had two talks. Basically, we had the one from Twilio, in which I got to know a lot about game design. I've never done anything around game design, and there was like quite a bit of similarity what actually Kevin told us. Like he did not know about anything related to game design, and when he started off with something, he used his experience of playing the games and actually implementing them later on while coding the whole thing. And it was a really interesting journey to actually look into. And then obviously this MongoDB talk for sure, like it was really enlightening in a lot of ways. And I'm totally gonna check out the new things what we have in Atlas, because I've just tried Atlas over the top. I want to try it a much more in deeper way, and that is actually what I will do after the stream today for sure.
Yeah. Now, we have Bew Humor asking what is next for the event. We have back our host from the last session, and we want to get into a few questions that people are asking in chat. I know, Lika, how do you feel after doing such an amazing talk about education and MongoDB?
Oh, it's been so much fun. I was looking forward to doing this today, so it's been great.
You guys hear me?
Mike is back.
You can hear me? I can hear you.
Anyway, it's lots of fun. I'm really happy to share stuff that we're doing with MongoDB, and it's also nice to talk to you and to talk to all of the amazing students listening and educators, of course. So yeah, it's fun. I'm really happy to be here.
So before moving forward to more technical questions, I would love to know, and this is kind of like gossiping, And I've always been curious about what is your favorite story from running Campus Experts, and then we can run to your current job at MongoDB.
Of course. Well, my favorite story, I have plenty, but what I really like and what every time surprised me is that I organized around all of the GitHub events, I organized this day where a campus expert could present something. And I was so impressed by the campus experts and how good they are and the knowledge they have. And those were the most inspiring days for me to organize something for them and then to get it run away, but to walk away from it being so inspired. That those were great stories, and that's why I like working with students a lot because they motivate me a lot every day. Yeah, and sorry, what was the
Okay.
other question?
You guys gonna write the question? All right.
How I joined MongoDB or
Oh, it was just moving from your story from GitHub Education. Now we can start talking about MongoDB, what you're currently working on. Josh, do you have any questions so far from chat?
Right. I have a few questions, but those are technical ones. I don't know if Michael can hear us at the moment or not. But anyway, one thing I wanted to know about, Lika, before that, is how was your experience at GitHub Satellite or GitHub Univers last year with all those campus experts you had with yourself?
Oh, that was amazing. I still talk about that. And it's also one of my favorite pictures. That's why I used it. Like I said, it's great to meet the campus expert in person because you onboard them and it's all through video calls. It's a bit like now. And then it's so important to hang out with them in person and to get to know them and also learn the stories behind them and behind their communities. And that's what I really liked. And that's what Satellite and Univers, it wasn't only an opportunity for the campus experts to come over and see us and meet fellow hubbers at that time, but it was also for me a very good opportunity to get to know them. And that's why I like those events and to hang out with them, to go bowling. I have tons of stories around that, which I should not say live.
Definitely. Okay, Juanpa, do you have anything else?
Yeah, so we have a couple of questions right now coming from the chat. And the students are asking, what would you recommend MongoDB for? And what should other alternatives be? But we can just focus on what would you recommend to use MongoDB for?
This is for me. I guess Mike is not here, or is he? I don't know.
She's
Should
getting
I
back.
Does he hear us? No. Well, I think I just take it, and I think I mentioned already a couple great examples. You can do tons of things with MongoDB. You can have wow, so many options. You can have the tracking database that I showed you, the web application that gives you information on COVID and everything that's happening. That's on MongoDB. You can create a blogging platform. You can come up with online games. I think I would also say keep an eye on our website for that though, because I'm interviewing tons of students doing great things with MongoDB. So that might help.
Amazing. Sounds
Definitely.
pretty good. Now, something that we wanted to know, and unfortunately, this is the last question that we have for today's session. What are you working on? Why are you interviewing so many students? What's coming up next? I mean, you talk a little bit about the work that you're doing and what's on this schedule, but why are you talking to all of these students? Are you trying to tell their stories? Can you give us more information about that?
Of course. Yeah, I'm talking to them. It's actually as part of the Student Spotlights program that we're working on. So to learn more about the students, about the projects that they're working on or that they worked on. And some are great. They turned into student startups. It's amazing. And then what's really nice for me is that it's also a good opportunity to learn a bit more on what they would like from us, like what can we offer in the future that makes a lot of sense, or that's something that they're really looking for. I'm hoping to come up with a program next year to do something more for students and educators, and that's for me a great opportunity to to interview all these students about that. So yeah, that if you have any suggestions as well, if you feel like, oh, MongoDB would be so great if you do this, just let me know, because I'm really open to thinking along and to see what we can do in the future, because it's very important to us, as I think I showed you before. So
Perfect. That sounds great. Okay, so now it's time for a break. So we have a 5 minute break coming over. And this is your chance to crush another mission into your quest, or head over to the Play track where you can hear a performance from the Australian XR artist Michael Brown. And yes, you heard it right. The music is being created in mixed reality. So check it out and come see us back in here in 5 minutes. Bye.
Everyone, welcome back. And what a show! It's really incredible the innovative ways people are able to use code to create art and music. We have solved some problems with dark, mysterious forces attacking our stream, but everything is sorted around right now, and we're pretty excited to be able to follow up with everything that we have planned for you. Let's see some emojis in chat for Michelle Brown. So let us know about some love, some emojis, some hearts in chat, some fire as well would be great. And if you were not able to see it, there's a recording available of all the sessions as well. They're going to be available, the ones from GitHub Education, at the Twitch channel that you're currently watching. Now, let's see some emojis watching here. I see Decina, DC2N14 joining in chat as well. So thank you all so much for staying around. And great. Next up on the university track, we have Amos Johnson and Dr. William Chris Headley. Amos Johnson is an associate professor at Morehouse College and has a research background in pattern recognition and discovery. He's even deployed a pattern recognition algorithm to identify people from their walking patterns. That's mind-blowing being able to do so. Dr. Chris Headley is the Associate Director of the Electronic System Lab at VT Hume Center, where he has worked on a number of large government and commercial projects. Within the lab, he oversees the radio frequency machine learning portfolio, and he serves as a mentor and advisor to the undergraduate and graduate researchers. His current research interests are spectrum sending, radio frequency machine learning, and educational opportunities in virtual reality.
Wow, this is really interesting. And I cannot wait to hear how they have been using GitHub to collaborate between their two universities in this totally remote world. Okay, so now let's welcome Chris and Amos.
Good afternoon, everybody. So my name is William Chris Headley, and I am the Associate Director of the Electronic Systems Lab at the Hume Center for National Security and Technology. And my colleague, Dr. Johnson, will be presenting this talk with me, and I'll let him introduce himself.
How you guys are doing? My name is Amos Johnson. I'm a college professor at Morehouse College. I've been there for about 15 years, and I'm in the computer science department. I'm originally from Georgia, and I've done all my education in Georgia, Morehouse College, Georgia Tech. So I'm a Georgia boy.
So this talk is a little different than probably some of the other talks. We're going to be talking about how we're using GitHub, not just for code organization and code development for a technical project. We're actually going to be talking about how we use it for a multi-college undergraduate research experience. And so for this presentation, I'm going to start by just introducing ourselves here. And then Dr. Johnson's going to give the background and motivation. And then he's also going to give a little bit of introduction on the first semester of the effort in the spring 2020 semester. And this was kind of mostly before COVID-19 hit. Obviously, we all know that has some unique problems associated with it that we're going to talk about today. Following up on that discussion and based on the outcomes of that semester, I'm going to talk about how we moved towards a GitHub focal point architecture for our project in the fall 2020 semester. And obviously, that's in the thick of COVID-19. And then finally, after I talk about that, Dr. Johnson, I'll hand it back over to him to give our final takeaways and thoughts on the project. With that, I'll hand it over to Dr. Johnson for the background and motivation.
Thanks, Chris. So this is a project that we call VIP. VIP stands for Vertically Integrated Projects Team. It's a team of students in undergrad, usually from sophomore to senior year, working together across disciplines to do some interesting research. And so what we made different is that usually VIP happens within one institution, but we wanted to do was create a virtual VIP team between two different institutions with two different geographic locations. So we got Virginia Tech Hume Center for National Security and Technology. They've been leader in radio frequency machine learning research for many years. And we have Morehouse College, and we're a historically Black college. And so the last 150 years, we've been preparing young men to change the world through ethical leadership driven by compassion, civility, and integrity. So one of our most famous graduates is Martin Luther King Jr. is one of our most famous graduates. We have some institutional goals that we're trying to do through the ICCA program, which stands for Intelligence Community Center for Academic Excellence. And our goal in terms of research is this joint collaboration of state-of-the-art RF technology and image recognition for spectrum sensing applications, right? Such as signal detection and modulation recognition. From a team goal, from a VIP goal, we're trying to create this collaboration to develop a framework between institutions that can be replicated in other places. The reason we're really doing this in terms of diversification is because if you go to an HBCU or even a non-R1 institution, R1 stands for Research One institution, what happens is you don't have the depth of experiences in different technologies that you would have at a Research One, like a Virginia Tech, like a Georgia Tech, like MIT or Stanford, those types of institutions, right? So these minority students who are at these HBCUs, they're lacking some research experiences that could advance their careers or could get them into certain graduate schools if they don't have those particular experiences. So this collaboration is really allowing us to kind of close that gap. And it's also giving students who are at a Research One, is giving them a broader experience. So when they develop problems, when they develop solutions, they can develop better solutions for a broader world. Next slide, Cliff. So here's an image of kind of what we're doing here. So we're using a thing called YOLO, which stands for You Only Look Once algorithm. It's a deep learning algorithm, and it's used mainly for image processing. So it takes an image, it can identify objects in the image in terms of detect where they are, and it also can do labeling of the objects in the image. So what we're doing is we're applying this technology to wireless signal spectrum. So you can take wireless signals, and you can create an image out of these wireless signals, and then you can detect where they are. You can do estimation, and you can do classification, right? And so that's our goal, is to test to see how we can do that in terms of research objective. From a student standpoint, we're exposing to wireless communication, spectrum sensors, and machine learning. And then just from a diversity standpoint, we're doing this through a diverse multi-college experience with many moving parts like data set generation, machine learning, testing, and evaluation. Next slide. So this is our pre-COVID semester, right? And so we say pre-COVID is when the world was normal, that we know about, right? And so in this pre-COVID semester, what you see here is kind of a chart of our demographics, right? We had two teams, roughly 50-50 on each side. We had Morehouse students and we had Virginia Tech students. So you can see the demographic data is there. From the Morehouse side, all the students were in computer science. On Virginia Tech side, we had a variety of majors from CS to engineering to different space, and also chemistry, right? And we can see the breakdown. We had way more males in this study than we had females. Of course, in Morehouse, we're only a male college, whereas Virginia Tech is a co-ed experience. We look at some of the challenges we had for this particular year was that, this is a brand new team project. We got minimal exposure to wireless communication technology, spectrum sensors, and machine learning, right? We got a diverse background of students, not just in ethnicity, but in gender, but in STEM, non-STEM majors. So we got a lot of diversity happening here, right? And we're trying to facilitate this inter-college collaboration with sub-teams with a mixture of Virginia Tech students and Morehouse students. So the really key there is that in these teams, really wanting to mix the students together. We didn't want to have an all Morehouse team and all Virginia Tech team. Next slide, Chris. So this goes into really kind of the heart of our presentation. So this is how we structured this. So in a pre-COVID world, the way this was structured is that the central hub there in the middle was in-person meetings in a laboratory experience. So at Morehouse College, I gathered my students together in a laboratory. Chris gathered his students together in a laboratory, and we teleconference each other into each other's physical space, right? So this kind of presented some problems, right? When you're meeting kind of once a week, right? And we found that it wasn't really granular enough to really account for a lot of the flexibility and facilitating a lot of the dynamic communication needed between these particular meetings. So we noticed these like 1 week lags, right? Also, when they wanted to reach out to me or Chris, we kind of had them come to our office, and we kind of had traditional office hours, right? And that kind of created some issues there too. And now in terms of actually communicating between students, this first semester actually was more student driven. It was the students who kind of brought GitHub to us, right? And it really had minimal interaction from the faculty, right? And we were only looking at the output they provided, right? And so this led to issues with, code breaking, right? It had some redundancy in code, people recoding the same sections because really there was no organized structure here. Students also brought in Slack in terms of communication structure. But here again, it's really for the students. It wasn't the faculty involved in as well. So if you look at our semester in terms of the pre-COVID last spring, it was really meeting focus. Like we're going to get together in a room in a lab space and we're going to interact through that particular space. And then you guys go figure out the virtual technologies. So that's kind of how it was. Next slide, Chris. And so let's look at some of the results of that, which are not bad per se. Right. Within a university, obviously the collaborations were better. Outside of universities, a little bit not as good. Right. But it's not terrible. It was not as good. Right. It was still that, I'm at Morehouse, I'm at Virginia Tech. Right. So we still kind of had that dynamic going on. Right. And so if you look at the graph there, you can, read the graph yourself in terms of experiences. But I want you to focus on some of the observations. Right. There was a decrease in positive responses in the collaborations among the sub teams. Right. And the second observation is there was a slight decrease in positive responses within collaborations among college. So which means that the collaboration wasn't as good when we start adding in the diversity pieces, right? And what we're about to get into next is Chris is about to talk about what we did in the fall semester under COVID, under a virtual environment, and we'll see how we fix a lot of these things. Go ahead, Chris.
Absolutely. Thank you, Amos. So as Dr. Johnson just mentioned, we had kind of this hybrid structure in the spring semester in which we had, in-person meetings at our particular institutions, myself at Virginia Tech and Dr. Johnson at Morehouse. But we also had virtual meetings where the whole team got together. And it was very focused on the students were driving most of the collaboration outside of the weekly meetings. And as we could see that there was some limitations to that. And what we wanted to, we took the summer 2020 period, and we said, okay, how can we improve upon this? And we made those changes based on our thoughts for the fall semester. And I'd like to talk about just what we did and what are the outcomes and how they compare against the spring semester. So let's talk about the team. So there was a couple of things different in the fall semester versus the spring. In terms of the demographics, actually, from the Virginia Tech perspective, it actually turned out that we kind of switched the demographics and we had a much more female-driven project from Virginia Tech. Obviously, Morehouse being an all-male institution was all-male in the demographics. The other thing is that based on how far the actual technical work got, which is not really a primary focus of this talk, we went from 2 sub-teams to 4. Because now the research has gotten more particular and we needed more sub-teams. The problem got bigger. There was more things to do. So we broke the team up into further sub-teams. So that's going to cause some issues because we saw that sub-team development and collaboration actually was lower than within a given sub-team. So we didn't want to amplify that effect by having more sub-teams. In terms of the majors, it's mostly the same. So Morehouse College is all of our CS students, and then Virginia Tech had, predominantly your STEM students. But we had an added wrinkle this semester that we also had some non-STEM, non-coding experience students from poli-sci and national security majors, which also added even more reason that we needed to better structure everything so that everybody could collaborate together with diverse experiences. And that's one of the key things that we want to mention here is that, we didn't want collaboration only to mean how many lines of code did you write? How many papers did you read? It's, did you help lead a team? Did you help lead brainstorming sessions? Were you involved? Because, with this diverse set of majors, it wasn't expected that everybody would have the same coding capabilities and the same background. So we wanted to make sure that our experience was more even playing field, as much as we possibly could. Obviously, COVID-19 university restrictions on both ends turned this project into completely virtual now. There was no in-person meetings, no in-person lab experience. They were all working from their own place, whether it be their dorm, the apartment, or at their family's home. And Dr. Johnson and I were primarily at our homes working. So a lot of new challenges here. In terms of the actual like project carryover, because of COVID, we actually did have some churn in our students. We got about, I would say, around 50% returning students. So there was the added challenge of, how do we get those new students injected into the project quickly? And that was very important for us to do. And another reason why we needed a better approach to collaboration. So I just wanted to bring this up. This is what Dr. Johnson mentioned, just so you can kind of see where we were and where we went. So I'm not going to spend time going over this again, but just remember that we were very, hands off in terms of the technical component. Dr. Johnson and I were meeting with the students as they needed it in in-person office hours and also during a weekly meeting. But they were pretty much running the show, the code base and everything. Which turned out to probably not be the best way to mentor students and get everybody involved and have accountability. So what did we move to? And that's kind of the key why we're here today, is we really moved to a GitHub project focal point. I'm sure everybody that's at this talk is at least partly familiar with GitHub, but GitHub really does provide a lot of tools that prove to be very beneficial for helping improve upon some of the collaboration and engagement issues that we had in the spring. And I kind of wanted to go over those and kind of enlighten folks that are listening to this talk on, how can they use GitHub for more than just obviously from a code technical standpoint? How can you engage students effectively and help them have good outcomes? So what do we got? So the first thing is GitHub issue tracking. This is, you assign issues that are related to the technical work to be done. Sometimes it's even, go fill out a survey or go set up a computer. But it was a central hub for all of the tasking that we had for the students. And what was very nice about that is they can set their own tasking. So while Dr. Johnson and I started by providing them tasks, as they found bugs or they found things that they wanted to add, they started owning the code and started making their own issues. Well, instead of waiting, for the weekly meetings, Dr. Johnson and I were able to see those immediately. We were able to see, clearly defined for this. We were able to clearly see who was doing what task and have real accountability. You said you were going to do this. You assigned it to yourself. How are you doing? So it was very easy to see at a glance what everybody was working on and to find maybe somebody that's falling behind or getting left behind. It focused the technical discussions instead of getting ad hoc emails or Slack messages or just in-person meetings about topics. There was no history of those meetings. It was very hard to collate, or I had to forward the same message to other people who weren't on the initial email. Having the discussion within the issues relevant to the tasking proved to be very beneficial for having a history of what was going on and for the other students to catch up. Even a student that really wasn't tasked with something, if they wanted to learn more about what was going on, they could go read the issue instead of being lost because they weren't on the email chain. So it was very beneficial. GitHub milestones, that allows you to, package a bunch of issues into a single milestone. That helped really with the inter-team collaboration. The teams knew how all of their issues that were assigned to their given subteam interplayed with each other to develop a higher level goal or, a feature to our code base. So it really helped students understand when they needed to collaborate amongst the subteams. So that was very beneficial. The GitHub Wiki, that was a one-stop shop for, installation instructions, IT resources, how to connect to our servers, technical references, research, literature review materials, anything relevant to the technical work. Instead of having it in 10 different places or having to forward it through email, it was a one-stop shop for the students, and they could even edit it themselves as they found interesting papers. And it kind of develops our catalog of useful information. And it really did lower the IT and faculty support for how do I get the code to run? How do I, access the server we're using? So very beneficial there. It's not also about, helping the students collaborate, but there is the fact that Dr. Johnson and I are not fully dedicated to this project because of our time allotment. So we need to make sure that we're using the best of the time that we have available. And these resources really helped with that. Protected master branches and pull requests, being able to lock down the master branch provided the faculty with clear interaction points. When they pushed code and said, I want to merge it into master, it gave me a clear point at which to look at the code and provide feedback. It also reduced the students breaking the code base so that they had to rely on other students fixing things before they could work it. They were working on their own branches. They were allowed to break those as much as they wanted, but the master branch must be protected. So it was a really interesting experience this fall that I think led to great outcomes that I want to mention here. So what are the collaboration outcomes? So what we're showing here is the spring versus the fall. And there's a couple of interesting things that you can see here. So first, the overall experience improved. We were still doing great. We're still kind of between good and great. So it wasn't a vast change, but it was certainly a marketable change. What's really interesting is, as you would expect, the same university performance was kind of level. You can see that in the top left plot. That's because, the same university went from in-person experience where it's a little bit easier to get in a room and whiteboard things out. Now they weren't in the same room. Everybody was virtual. But it did help the between university. It kind of leveled the playing field. And we're going to talk about that in a minute. So really, and this is what's really important, is it really helped the collaboration, not only between the sub-teams, but between the universities with a very small decrease, even though we went completely virtual, between same university experiences. So, having to deal with all this and still showing improved results, I think is a great result. And I really do think it's because of, this GitHub focus, this one-stop shop for all of this material. So we were very happy with that result. I'll quickly go through the next slides. This is just the technical outcomes. I just wanted to show that, the students not only did, they felt like they collaborated more, but they really felt like they were learning the technical material. They felt like they learned more about wireless comms, machine learning, and spectrum sensing, which is really what we were aiming to do from a technical perspective, because these are not typically taught in their undergraduate coursework, or at least not until their late senior years. One of the things we did notice, though, is that sub-teams that weren't dealing with machine learning didn't really learn as much machine learning, and same thing for the other sub-teams. So we really think that one thing that we can do, with that GitHub focused architecture in the spring 2021 is have the sub-teams be in charge of the pull requests in a kind of a random fashion or in a cycle fashion, so that each of them can experience the whole code base more often. I think that'll be extremely useful for them to understand holistically the technical contributions of the effort. So this is kind of important, I'm sure, to the audience here. The GitHub outcomes, we'll just say that, they felt that they strongly developed a knowledge for Git and GitHub and code development. And they felt the GitHub repository, if you look at the bottom right, was great experience for them, or a good experience for them. So they really enjoyed that. I put some select quotes here for the GitHub outcomes. They thought GitHub was a very effective way to show our progress and what we're working towards. Kept them with things to do. It was great seeing deadlines and what was assigned. Again, that accountability. But this person said, I never used it before, GitHub issues before, but I really liked it. It was a very effective way to track changes or track tasks, and keep people accountable. So you can see that it made the students feel better because they knew what they were working on. They knew that other people weren't falling behind. Everybody was accountable and they felt like a team. So I think this was a really great outcome. So with that, I'm going to pass it back over to Dr. Johnson to kind of take us home with the takeaways and thoughts of this year of these last 2 semesters of work.
Yeah, thanks, Chris. So a couple of takeaways we want to let you guys know about is that moving to the GitHub focus approach to team project coordination, it really improves student and faculty outcomes, right? it really brought the project together in a way that we didn't have in the first semester. With issue tracking, milestones, and allowed for a much easier project tracking and technical discussions, right? We had minimal email traffic. We didn't need to forward information back and forth between people. It reduced the IT infrastructure and burden and increased accountability and trackability between students. Also, with the diversity of students and their backgrounds and multi-colleges, I think from Chris' perspective, he really rewarded the challenge of understanding how to best assign tests and to teach and mentor the different concepts, right? I think every student connecting virtually really removed the institutional bias and closed the distance gap. When we had some people in the lab and some people not in the lab, it really kind of was this weird thing. And even the collaboration between me and Chris and the other partners in the all virtual space, it kind of put everybody on the same playing field. A couple of things, if you want to try this yourselves, you really want to maybe look at having some graduate TAs to help fill in some of the knowledge gaps between students. And if another thing I want to throw in too is GitHub want to add a communication layer like Slack. I think that'll be helpful too. So we have to switch out to like Teams. Chris, you want to give the final word?
Yeah, I would just say that, you would think in a COVID world that, things would have just gotten worse. And what we noticed is, obviously, we wish that there's no replacement for a real whiteboard. I love a good whiteboard, being in person, getting that, nearby experience, having the students in the lab. We do miss that. But, there's something interesting that kind of came about this, about, if you're working virtually and, having everybody, in this case, Zoom, where you're seeing everybody's faces, it's like you're talking one-on-one, but in a group setting, that whole, leveling the playing field, it almost felt more personable in some ways, which was not what we expected at the beginning. So, I think there's, some threads to pull there, how we can do this virtual experience, this remote, how do we bring people together virtually at different institutions, and how do we scale this if we had 3 or 4 institutions? So I think there's a lot of work to do, but I think, COVID, obviously, wish it never happened, but, there's been some unique takeaways that have been benefits that have helped us in this process. And, we'll take what we can get and are positive in this COVID world right now. So, that's it. I'll say, So questions, obviously there's no live Q&A here, but here's our email addresses. If you'd like to reach out to myself, my email's at the top, and Dr. Johnson email at the bottom there. And I'll just say thank you very much for listening to this talk. Dr. Johnson, any final word from you?
No final words. Just thanks for having us on. I appreciate our time together.
Yeah, and thank you very much to GitHub for the experience. This is a very unique venue, and we're happy to participate. Thank you.
Thank you so much, Chris and Amos, for joining us today. It's really incredible to see 2 universities coming together like that while using GitHub to increase collaboration and engagement for students, right? I thought it was particularly interesting to see the transition from the spring semester to the fall semester. Like, it was the focal point in the spring semester to use like videos and video calling. And later on, they focused on using GitHub as the focal point, using GitHub milestones, GitHub wikis, issue tracking, and everything, according to their research, was pretty much like better on like the average side of it. And it's really interesting that this could actually lower the time involvement of a lot of people and also increase the productivity there, right? So, Juanpa, you did quite a bit of research yourself as well during your degree, didn't you? So what did you focus on?
So I did 2 types of different research. I worked with collaboration platforms. That was a research paper we built with Stanford University. It was a lot of fun, very similar to what Amos and Chris did here. I think something that I would love to see looking forward at this kind of work that these teachers are doing is how they're going to be implementing discussions well. And I think that's going to be one of those things that will help everyone to go faster through Q&A, avoid students asking the same questions, or having an easy way to link folks to answers to questions that they have on the class, so that if one student just asked it one question, they can just reference that link and solve that at scale. The other research that I did was among Twitch, where we tried to see how Twitch is going to be working. And this was just after Amazon acquired Twitch. So getting to know the platform, how audiences work. And we have a couple of papers already on that published on ACM, which was pretty exciting. And I agree with Chris and Amos. Collaboration between universities should be something that we promote more, and is something that it brings a lot of value to students and researchers at the same time. Now, Josh, I know that you were a mechanical graduate, right? But how did you work as a software developer throughout your time at the university? How does that all work out?
Right. And actually, to be honest, this is like the most asked question to me, like how as a mechanical engineering graduate, you got into the software development field in the first place. And I was like, see, whatever you want to do, whatever you are trying to do is not related to the degree or the things you are pursuing in your academia. There's a lot of great folks I know there that are from maybe the psychology part, and they are doing great in the software development, developer relations, and everything like that. So it's basically, I wanted to do that. I knew I can do that. I was actually involved in open source a lot. I was involved in the GitHub Campus Experts program and different other communities. And that actually shaped me to do whatever I wanted to do, got to me at this point for sure.
Yeah, and just like the talk that we had yesterday from Amoju, finding that middle point between what you were studying and coding can be a great place to start learning new coding skills or developing skills that might be valuable for you, not only as a mechanical engineer, but also as a software engineer. Well, up next, we'll be hearing from Kevin Backhouse. Kevin is a member of GitHub Security Lab, where he focuses on finding vulnerabilities in open source projects. He became a security researcher in 2017 after working as a software developer for 15 years. His current focus is on helping to improve the security of his favorite operating system, Ubuntu. So please welcome Kevin Backhouse to the GitHub stage.
Hi, my name is Kevin Backhouse and I'm a member of GitHub Security Lab. In this short presentation, I'm going to try to give you some tips on how to get started in security research. I do want to start with an apology though. I was a professional software developer for 15 years before I got started in security research. I expect many of you who are watching this are younger than me, and so my story of how I got into security research as a kind of mid-career pivot isn't necessarily going to be all that relevant to you. But one of the things I want to emphasize is I don't think there is a standard path in security. I kind of got into it by accident myself, and I really enjoy it, and so I want to encourage any of you who are watching this to consider giving it a try. Security is kind of an unusual field. Some of the most accomplished security researchers in the world were either self-taught or did not come from a formal computer science background. Two of the most talented researchers I know actually studied journalism in college. Now, I did study computer science, and so I'm certainly not trying to argue that a computer science degree has no value. But I do wonder whether maybe some of the personality traits that make certain people particularly good at spotting security vulnerabilities are maybe things that they can't teach you in college. So I thought I'd start with the story of how I got my first CVE. This is an excerpt of a security bulletin published by Apple in 2017. So every time they release a new version of macOS or iOS, they publish one of these bulletins which has a list of vulnerabilities that were fixed, and they acknowledge the people that found them. And that's my name down there in the bottom. Now, if you haven't heard the acronym CVE before, it stands for Common Vulnerabilities and Exposures. So every time a vulnerability is found, a unique CVE ID is assigned to it. And it's useful for tracking, and it's also very useful for systems administrators so that they can check whether the software that they're running contains any known vulnerabilities. And really my main job as a security researcher is to get CVEs. I kind of like it because it makes my job very measurable. I can track my performance by the number of CVEs that I'm getting. Now, of course, some CVEs are a much bigger deal than others, but I know that as long as I've got a reasonably steady stream of CVEs coming in, that I'm doing okay. So getting back to my first CVE, back in 2017, I was on the C and C++ analysis team at SEML. That was before SEML was acquired by GitHub. And at that time, we were beginning to realize that CodeQL had a lot of potential as a tool for finding security vulnerabilities. That's because it's very easy to create new custom queries. And so that means that it's realistic to write a CodeQL query that is designed to look for a specific kind of bug in a specific code base. Now, we were a startup, and so we were always looking for new customers, and we were particularly keen to sign up high-profile tech companies like Apple. So we decided to try writing some custom queries for the XNU kernel. So XNU is the kernel used by both macOS and iOS. I started by looking at the results of our default queries, and one of the things that stood out at me was that this file called dtrace.c had an unusually large number of results. Now, at that time, a lot of our default queries were not focused so much on security and more on things like code cleanliness. So a lot of the results that those queries were finding were not security vulnerabilities, and in many cases not even bugs. But the fact that there were so many in this particular file drew my attention to it. And so I decided to take a closer look. And to my amazement, I discovered that it contained an interpreter. So you can see here that it's reading instructions out of an array and then evaluating them. And so what this means is that somebody has made it possible for me to write a script and have that script get executed by an interpreter that lives inside the kernel. Now, I'm not an operating system expert, but I've always assumed that they're written very conservatively and designed to be absolutely bulletproof. And so it was mind-blowing to me to discover that there was an interpreter just sat there in the code. So I had this Venn diagram in my mind. If you were to think about all the developers in the world, then there's going to be a subset of those developers who are particularly meticulous and are very good at writing code that doesn't contain any bugs. There's also going to be a group of developers who think it's a great idea to embed an interpreter in security critical software. So that team over there are responsible for numerous dumpster fires, including modern web browsers. Now, I'm not saying that the intersection between these circles is empty, but I am saying it's small. So I was absolutely convinced that I was going to be able to find a bug in dtrace.c, in that interpreter. So what I did was a combination of manual audit and writing a custom CodeQL query. So it was clear to me that I could completely control the values in this array called regs. And so what I was interested in is whether one of those values from regs that I could control could flow to a place where it could cause something bad to happen. So for example, be used in an unbound check array access, for example. So let me show you the CodeQL query that I wrote. So over here is the query. And so it's using a data flow. It's using data flow to find paths from sources to sinks. And as the sources, I've defined this class called register access, which finds places where we're reading from the regs array. And then for the sinks, it's looking for places where there's some kind of pointer access. And over here on the left, you can see the result of that query, the interesting result of that query. And so down here, this is where it's doing a pointer dereference on something with arg in it. And if you trace that back, you can see that that came from there, which came from this function call, which came from that parameter, which came from here, which is this access of the regs array. And so it turns out that you could get the kernel to read from kernel memory at an arbitrary offset by setting the value of regs at position R2. Now, I mentioned earlier that one of the things I like about security research is how measurable it is. You can rate your performance by the number of CVEs that you're finding. And I think that this focus on concrete, indisputable evidence is one of the themes of the field. This is our motto. So people in security research have had absolutely no time for the kind of abstract pontificating that academics sometimes like to do. If you want to claim that you found a security vulnerability, you have to prove it by creating a POC, which stands for proof of concept. So over on the right-hand side here, this is an excerpt of the POC that I wrote for the dtrace vulnerability. And if you want to see the full thing, then you can go to this URL. Now, writing this POC was actually quite a lot of work. dtrace uses an object format somewhat like the ELF object format on Linux. And so I had to figure out how to create a valid dtrace file in order to trigger this bug. And I didn't know how to debug the macOS kernel. So what I ended up doing was extracting the parsing code from the source code in order to create a little test harness so that I could test the dtrace files that I was generating to try and check that they were valid. But when I finally thought I had a dtrace file that would trigger the bug, I tried running it on a real Mac and nothing happened. It was one of those cases where there wasn't even an error message. It was just nothing. And it took me several more days of studying the code, the source code of the kernel, to figure out what I'd done wrong and how to fix it. And I was on the point of giving up before I finally managed to crash the kernel. So this is what that looks like. Now, I stopped there. Once I got to the point where I had a POC that was able to crash the kernel, I didn't then continue and create an exploit that was able to do something like escalate privileges. And I think that's generally considered okay. Once you've got a POC that can cause something clearly bad to happen, then that's sufficient to get a CVE. But you definitely get higher marks for creating a full exploit that actually does something like escalating privileges. And so recently, that's something that I've really been focusing on doing. And a lot of it is because I want to be able to call myself a true security expert. And I feel that in order to be able to claim that, I need to understand how to write exploits. So that's the end of my story about how I got my first CVE. What happened next was that Uche de Moor, who was the founder and CEO of Semel, decided that it would be quite a good idea for the company to have a small security research team. And he asked me and my colleague Manu Mo if we'd like to become full-time security researchers. I was a bit apprehensive about it at first because this bug definitely felt like a fluke to me when I found it. And I wasn't convinced that I was going to be able to find anything else like it. But over time, what I've learned is that almost all software contains vulnerabilities. And if you look hard enough, then eventually you'll find one of those vulnerabilities. Now, I want to just explain a bit about the security field as a whole. I've specialized in a very small part of it. In particular, I'm in the secure code area, which means that my job is to look at source code and try to find bugs in those source code. So there are many other areas outside of that, for example, multi-factor authentication, automatic phishing detection, antivirus, even physical security that are outside my areas of expertise. Within source secure code, as GitHub Security Lab, we focus exclusively on open source code. So that's quite a big distinction with other security research teams who are often reverse engineering proprietary source code to find vulnerabilities in them. And I, as a former developer, I'm particularly comfortable with C and C++, so that's what I tend to focus on. If you're not already familiar with those languages, then I wouldn't necessarily recommend that you try to get into that niche, because in the modern world, languages like JavaScript and Python are becoming increasingly important, and so it might be more profitable to focus on those. So when I talked about the dtrace vulnerability, I talked about two of the techniques that I use, which are static analysis, or CodeQL in my case, and manual audit. There's a third technique, which I don't use so much myself, but is often incredibly effective, and that's fuzzing. The idea of fuzzing is to hammer an application with randomly generated inputs until it causes a crash. And I think the reason why this is so effective is because often when developers are writing their code, they test it with valid inputs and they forget to think about what might happen if the code were presented with an invalid input. So the way that a fuzzer often works is it starts with a number of valid inputs and it starts making small changes to them to see what other code paths might get triggered by that. And they're often able to uncover weird edge cases that sometimes turn out to be exploitable. I think fuzzing is particularly effective on dense file formats like images, because if you make a small change to an image file, it's quite likely to still be at least partially valid, and that might then trigger a new code path and uncover one of those edge cases. Probably the most well-known fuzzer is called AFL. So I'm going to show you a quick demo of how easy it is to get started with AFL. So I'm going to show you how to run a fuzzer on Exib2, which is a project that I've occasionally helped out with. So what you have to do is you have to rebuild the application with an AFL specific compiler. So you can see here AFL Clang Fast is the compiler that we're going to use. And I've also switched on ASAN, which stands for address sanitization, and that's going to help to find bugs like buffer overflows in the code. And we just run make on that. And then over here in the other window, so I've got a directory that contains a number of image files to use as seeds for the fuzzing. And then we can run the fuzzer like that. And so here it's scanning through those input files, creating initial database to use for testing. And in a second or so, it should be done with that and it will be ready to go. So you're typically going to need to leave AFL running for hours, if not days. And when it starts finding crashes, it will start to show that here. With a bit of luck, you shouldn't find anything on Exib2 because I've already run AFL and I think I found everything. But the instructions should be pretty much the same for other projects as well. So I wrote a blog post earlier this year which has detailed instructions on how to run that demo on Exib2. I do recommend, if you're going to try those, grab yourself an Ubuntu 18.04 VM, because those instructions were written for Ubuntu 18.04. So hopefully they'll work straight out of the box if you have an 18.04 VM. I also recommend, if you're interested in fuzzing, then my colleague Antonio Morales has written a number of really good blog posts about it. This is the first of those, and there are more if you go to this URL. Okay, so there's a couple of final points I want to make about the techniques that I've mentioned. Static analysis and fuzzing are quite different approaches to finding bugs. Static analysis is really good for scanning large code bases and finding interesting places to look. And what I've often found when I've used CodeQL is that I've had to then work backwards from a potential bug to figure out how to trigger it. So for example, last year I found a vulnerability in Facebook's TLS implementation. And it was on a code path that wasn't normally executed. And so I had to work backwards and figure out some unusual options that you had to send to the TLS server that would cause that code path to get triggered. Now, with fuzzing, it's the opposite way around. You start by identifying what the entry points are into the program, and then you point a fuzzer at it, and it will then start to explore the code paths that are reachable from those entry points. But I think that no matter what you do, no matter how you find the bug, you always end up doing some manual audit. And that's partly because when you do find a bug, you need to thoroughly understand why that bug happened so that you can write a helpful bug report to send to the maintainers of the project. But also, of course, if you are planning on writing an exploit for the vulnerability, then you're going to have to really understand that area of the code in order to figure out how to exploit it. In the abstract that I wrote for this talk, I said I was going to talk about the bug finding techniques that I use, but I also said I was going to talk about the difference in mindset between a security researcher and a developer. In popular culture, there's this image of what a hacker looks like. I've included some examples on this slide. Now, I don't look like that. Maybe I should try wearing more black clothes. I don't think I'm going to be able to pull off that hair, but I could maybe try getting some tattoos and piercings. I wonder what my kids would think of that. Jokes aside, though, I don't think that this image of what a hacker is completely wrong. I think there's an anti-establishment mentality that is really important. As a security researcher or hacker, you do have the ability to embarrass huge, powerful companies, but you can only do that if you don't believe their hype. You have to be convinced that they've got bugs in their code and be willing to keep hammering at it until you find them. The reality of security research is a lot more boring than what you see in the movies, though. This is one of my favorite tweets. It's from Ned Williamson, who's one of the Google Project Zero researchers. And this is actually one of the things that I really enjoy about security research. It's since becoming a security researcher, I've actually learnt about all kinds of software that I'd never bothered to look at before. So it's making me much more knowledgeable about how the technology around me works. I do have a word of warning about what it's like to be a security researcher. It feels to me a lot like a competition. You don't get to rest on your laurels for very long. There's a brief moment of triumph after you've found a bug where you get to publish your exploit video on Twitter and write a blog post about it. But then that bug is burned and you're back to square one looking for a new one. And I know from experience that sometimes you go through periods of time where you're just not finding anything. I think maybe it's a bit like being a professional baseball player. They sometimes go through slumps where they're just not getting any hits, sometimes for weeks on end. And so that can make it quite high pressure. And people do burn out. So please take care of yourself and remember that it's actually a slow grind. You just have to keep looking and keep working at it, and eventually you will find the bugs. So let's answer the question that we started with. How do you get started in security research? My recommendation is choose a project to focus on and really study how that project works. I recommend going for something open source because then you can read the source code, which makes it a little bit easier to figure out what's happening. You can also go on the bug bounty programs like HackerOne, for example, to get recommendations. I would suggest that you don't try looking at something really high profile like Chrome or Firefox, because a lot of security researchers have already looked at those projects, and so the bar to finding something new is really quite high. And of course, use all the tools that are at your disposal: static analysis, manual audit, fuzzing, anything that you can do to help you find the bugs. If you do find a bug, then here's a few tips on how to report that properly. So first of all, if at all possible, try and report it privately. Posting an issue publicly on their GitHub repo is a last resort if you can't find an email address to send it to. Always be polite. And I think the third one is particularly important. Clear reproduction steps are so important. So a POC that is easy for the maintainer to run and confirm that what you're saying is true. Try to explain the bug so that they understand what it is that they need to do to fix it, and explain why it's a security issue. And it's probably a good idea to include your disclosure policy. So 90 days until public disclosure is the kind of usual thing. And you can take a look at our security policy to use as an example. So for my final slide, I made a little hacker glossary. I think the security world has always had a lot of inside jokes and terminology, or since 1992 AD, as my colleague Bass would probably say. So these are a couple of the things that I've had to look up. Hopefully they'll be helpful to you too. Thanks for watching.
Thank you so much, Kevin, for giving us a great narrative about your journey as a security researcher here at GitHub and how you have found bugs in different platforms, replicated those bugs, and shared how to report them. So now we're reaching the end of the second day of GitHub University. But we're also pretty excited to tell you about what's going to be happening tomorrow.
Right, and tomorrow will be a pretty exciting day for sure. It's the day we celebrate our community and the role of community in software development. I know it's the people and the connections I've made through the Campus Experts program, through open source, and through Major League Hacking that keep me motivated and made this as such a rewarding industry to work in. I can't wait to share some of that with you all tomorrow. Unfortunately, Juanpa will be leaving us tomorrow as the host, but don't worry too much. He'll be back with a super special speaker announcement about the GitHub Campus Experts program. I cannot wait to get back on stage with the GitHub Student Program Manager Elise tomorrow, who you saw in day one of GitHub University for sure.
Well, that's right. Tomorrow we'll be talking about the 3 pillars of the GitHub education programs. That's Campus Experts, our student superfan program, and how we support you all to build communities on your campus. Then we'll be talking about Campus Advisors, our program for teachers. And I don't know about you, but after hearing Chris and Amos, I know these teachers are the ones that I wish I could have in my campus. Campus Advisors is a really incredible program and has all sorts of benefits you can bring to your teachers. Not to mention getting you access to swag in the classroom as well. Finally, we'll be rounding up the day with the GitHub Campus program. That's GitHub integrated throughout your entire campus. Imagine having support on your CS assignments at any stage in the process, homework assigned through GitHub Classroom, and all the tools and resources your campus needs to bring you the best education and prepare you for your first job. I can't wait to share you with everything I've been working on the last few months to make Campus Experts even better. So make sure to tune in and hear what's new. Now, Josh, we have been going through Twilio Quest as well. And even though we are not currently having access to the leaderboard, can you tell us a little bit about the experience and what do you expect from Twilio Quest right now?
As I see from the total XP points, we are had 536,875. That's like the most experience point I've seen in Twilio Quest at the moment. It looks like we have well on the way of saving the flame of open source. Keep playing for getting more chances to swag raffle, and you will be definitely winning one for sure. So there's still a lot of content happening out there. We highly recommend you heading over to the developer tag for the closing ceremony. You can hear highlights from the day and learn about the announcements on the other tracks as well. So that was all for today. Thanks a lot for joining us at GitHub University today. See you all tomorrow. Bye.
See you tomorrow. Bye-bye.